Welcome back, student. In this video I am going to discuss the synopsis of solid state physics and digital electronics, or it is also known as semiconductor electronics. Solid state physics and digital electronics or semiconductor electronics. So in this chapter we are entirely going to discuss about semiconductors and the digital electronics. Okay, so start with the synopsis. Now here, first one, to start with, band theory of solids. Band theory of solids. You know, there are two types of bands. One is conduction band and other is valence band, as you can see in the picture. All of you know that what is a conduction band and what is a valence band. First I will discuss about valence band. What is valence band? Valence band is the energy band which is having valency electrons, and it is the outermost orbit of the atom. It is the outermost orbit of the atom. Okay, so once again, what is valency band? Valency band is the outermost band which contains valency electrons, and conduction band is what? Conduction band is the band which contains conduction electrons, means free electrons. What is meant by conduction electrons? Free electrons. So you can see free electrons are available in conduction band and bounded electrons are in valency band. So on this basis of conduction band and valency band, how the band theory of solids differentiates conductors, semiconductors and insulators. What are those? Conductors, then semiconductors and insulators. So how you can differentiate the three? Semiconductors and insulators. Okay, so on this basis we have to discuss these differentiation: conductors, semiconductors and insulators. In conductors, the conduction band and valency band, you can see here the two bands overlap, whereas in semiconductors, conduction band and valency band are differentiated by some energy gap, that is called forbidden energy gap or forbidden energy level. So what is forbidden energy gap? The band gap between conduction band valency band is called forbidden energy gap, or it is called band gap. The energy difference between conduction band and valency band and here in the conduction band the lower energy level, and in the valency band higher energy level. The difference between the lower energy level of conduction band and the higher energy level of valency band. If forbidden energy gap is almost zero, means conduction band overlaps on valency band, this is what conductors, or also called metals. And in semiconductors there is small gap between conduction band and valency band. It is about 1 electron volt, that is in semiconductors. And in insulators there is a large energy gap between conduction band and valency band, it is nearly about 6 electron volt. They are called insulators. So now we go for second part, that is resistivity of the different materials, that is metals. Metals are also called conductors. Metals are what? They are also what? Conductors. Metals means conductors. Okay. Semiconductors, you know, semiconductors and insulators. In conductors, resistance is low. In semiconductors, it is medium, and insulators, resistance is very high. You can see the range. And next, there are two types of semiconductors. They are intrinsic semiconductor and extrinsic semiconductors. Intrinsic semiconductors are also called pure semiconductors. Intrinsic semiconductors are also called as what? Pure semiconductors. And at room temperature, there are current carriers, they are called holes and electrons. These are holes and also known as free electrons. Free electrons are simply called electrons. So what are the charge carriers or current carriers in semiconductors? Holes and free electrons or electrons. At any instant, the number of holes is equal to number of electrons, in which case intrinsic. And at 0 Kelvin, you are getting filled valency band and empty conduction band, and at 0 Kelvin, conductivity is 0. Means at 0 Kelvin, the conduction band is completely empty. Conduction band is completely empty. Only the electrons are available in valency band. So thereby, if conduction band is empty, no free electrons available, no free electrons, no current. That's why the conductivity at 0 Kelvin is 0 for intrinsic semiconductors. If you increase the temperature, the conductivity of the intrinsic semiconductor increases, because in pure semiconductors, you can see, take germanium. Germanium is bounded by 4 valency germanium atoms. 4 valency germanium, 4 germanium atoms. So each germanium atom makes covalent bonds with neighboring 4 germanium atoms, and as you increase the temperature, some of the electrons break the bonds. When the electrons break the bonds, the electrons comes out, thereby creating a vacancy. Means one electron causes one hole. That's why electrons and holes are equal in number. ಅಂದರೆ ಏನಾಗುತ್ತೆ, ವೆನ್ ಯು ಇನ್ಕ್ರೀಸ್ ದ ಟೆಂಪ್ರೇಚರ್, ಒಂದು ಎಲೆಕ್ಟ್ರಾನು ಬಾಂಡ್ಸ್ ಬ್ರೇಕ್ ಮಾಡಿ ಹೊರಗೆ ಬರುತ್ತೆ. ಹೊರಗೆ ಬಂದ ತಕ್ಷಣ ಎಲೆಕ್ಟ್ರಾನು ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ ಆಗುತ್ತೆ. ಆ ವೆಕೆನ್ಸಿಗೆ ಹೋಲ್ ಅಂತ ಕರೀತಾರೆ. ಅಂದರೆ ಒನ್ ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ ಮೇಕ್ಸ್ one free electron makes one hole. That's why the number of free electrons are equal to number of holes. And if you increase the temperature, conductivity also increases. Next topic, fifth point is in extrinsic semiconductor. So extrinsic semiconductors are also called impure semiconductors. So impure means some of the impurities are added to these semiconductors. So that's why they are called doped semiconductors. Means the impurity is added. At room temperature, the majority current carriers are either holes or electrons. Means if you increase the temperature and if you increase the doping also, the number of electrons and holes becomes unequal. If the electrons and holes are unequal, one is more a number, another is having less number. So that's why there are majority carriers which are having more number. The numbers which are less, they are called minority charge carriers. They may be either holes or free electrons. ಅಂದರೆ ಏನಾಗುತ್ತೆ, ಟೆಂಪ್ರೇಚರು ಡೋಪಿಂಗು ಎರಡೂ ಹೆಚ್ಚು ಮಾಡಿದಾಗ ಎಕ್ಸ್ಟೆನ್ಸಿವ್ ಸೆಮಿಕಂಡಕ್ಟರ್ ಒಳಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸು ಹೋಲ್ಸ್ ನಂಬರ್ ಏನಾಗುತ್ತೆ, ಅನ್ಈಕ್ವಲ್ ಆಗುತ್ತೆ. ಅನ್ಈಕ್ವಲ್ ಆಗೋದ್ರಿಂದ ಯಾವುದಾದ್ರೂ ಒಂದು ನಂಬರ್ ಹೆಚ್ಚಾಗುತ್ತೆ, ಐದರ್ ಹೋಲ್ಸ್ ಅಥವಾ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಯಾವ್ದು ಹೆಚ್ಚು ಇರುತ್ತೆ ಅದಕ್ಕೆ ಮೆಜಾರಿಟಿ ಅಂತಾರೆ, ಯಾವುದು ನಂಬರ್ ಕಡಿಮೆ ಇರುತ್ತೆ ಅದಕ್ಕೆ ಮೈನಾರಿಟಿ ಅಂತ ಕರೀತಾರೆ, ಮೈನಾರಿಟಿ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ಸ್. There are two types of extrinsic semiconductors, that is P type and N type. What is P type? P type is obtained by adding a trivalent impurity and the majority charge carriers are holes. ಅಂದರೆ ಏನಾಗುತ್ತೆ, when you take a germanium atom, when germanium atom is replaced by what in impurity, that is trivalent impurity, that is indium or gallium or aluminum or boron, ಯಾವುದಾದ್ರೂ ಒಂದು ಇಂಪ್ಯೂರಿಟಿ ಅಟಮ್ ಆ್ಯಡ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಹೇಳ್ರಿ, ನಾವು if you replace one germanium atom by indium, so what indium makes? Indium makes 3 covalent bonds with the neighboring 3 germanium atoms, but one bond is left free. In indium, one bond is left free because it is having only 3 valence electrons. Trivalent impurity means 3 valence electrons. Indium makes 3 covalent bonds with the neighboring 3 germanium atoms, but one vacancy is created, so that now indium takes 1 electron from neighboring germanium, so it fulfills its bond formation, but 1 electron got from other germanium, it indicates one vacancy is created in the germanium. That vacancy created is what? Nothing but hole. That's why if you go on increasing indium impurities, the holes population goes on increasing. That's why the majority charge carriers for p-type, that is trivalent impurity adding, makes holes as majority charge carriers. And here some of the electrons are left free because of the increase in temperature. ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಪಿ ಟೈಪ್ ಒಳಗೆ ಟ್ರೈವೆಲೆಂಟ್ ಇಂಪ್ಯೂರಿಟಿ ಆ್ಯಡ್ ಮಾಡೋದ್ರಿಂದ ಹೋಲ್ಸ್ ನಂಬರ್ ಹೆಚ್ಚಾಗುತ್ತೆ. ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸು ಇರುತ್ತೆ, ಬಟ್ ನಂಬರ್ ಆಫ್ ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಲೆಸ್ ಕಂಪೇರ್ಡ್ ಟು ಹೋಲ್ಸ್. ದಟ್ಸ್ ವೈ ಹಿಯರ್ ನಂಬರ್ ಆಫ್ ಹೋಲ್ಸ್ ಪಾಪ್ಯುಲೇಷನ್ NH greater than number of free electrons. NH greater than Ne. Okay. Now, okay, next. After this, next we go for P-type. N type. What is N type? N type is obtained by adding pentavalent impurity, that is arsenic, antimony. Sb means antimony or phosphorus. Arsenic, antimony or phosphorus. These are the pentavalent impurities. By adding pentavalent impurity, we get more number of free electrons compared to holes. That's why free electrons are majority charge carriers. Ne is greater than Nh. So number of free electrons are more than number of holes. That's why here holes are called majority charge carriers. Electrons are called majority charge carriers. Once again repeat. Electrons are called majority charge carriers in N type. And holes are minority charge carriers. Okay, which impurity added? Pentavalent. In what? N type. P type, trivalent impurity. Majority holes. Okay, next point. Extrinsic semiconductors are neutral. They are neutral. Don't think that P type is positive type, N type is negative type. Not like that. P type means positive type semiconductor, means it is not a positive terminal. N type means negative type terminal, it means it is not negative terminal. P type means only that holes are majority. P type, holes are majority. Holes means positive. In N type, there are electrons are majority, so that's why it is what? Negative type. But they are electrically neutral. Once again I will repeat, don't think that P type means positive terminal. It is positive type, means positive charges are more, means holes are more. N type means not negative terminal, it is negative type, means electrons are more. Electrons means negative charges are more. When N type or P types are heated, the number of electrons and holes increases equally, because due to increase of heat or temperature, the electrons breaks the bonds, thereby creating holes. Means one electron breaks one hole, one electron breaks the bond, makes one hole, means one electron makes one hole. 10 electrons breaks the bond, 10 holes. 100 electrons breaks the bond, 100 holes. That's why number of electrons holes increases what? Equally. In what? Either N type or P type. Due to what? Heating, not due to doping. Due to heating. Okay. Next point, at 0 Kelvin temperature, a P-type semiconductor has a few holes and no free electrons. 0 Kelvin temperature, either you take a P-type or N-type. At 0 Kelvin temperature, a P-type semiconductor has few holes and no free electrons. Why? Because at 0 Kelvin temperature, some of the atoms are doped, means doping will cause, in P type, doping will make holes. That's why no free electrons available. Because there is no increase in temperature. But if you increase the temperature, holes also increases, free electrons also increases. So next point, holes can exist only in semiconductors. As you know, conductors are having only free electrons. Semiconductors are having both holes and electrons. Okay. Next is diode. Diode means what? Diode as a rectifier. It is given as diode as a rectifier. Okay. What is a diode? Diode is a PN junction. You can see PN junction. What is diode? It is a PN junction. When P type and N type are mixed, the junction is formed and it is called PN junction or simply diode. And diodes are used for rectification. Rectification means conversion of AC to DC. Works under bias, reverse bias condition used in switching circuits. That is photodiode. Photodiode is used what? And a PN junction is in reverse bias mode. Some of the light incident will make the current to increase. When the light is incident, the reverse current increases. That becomes what? Photodiode. And LED. LED means what? Light emitting diode. It under forward bias mode. Under forward bias mode, the diode emits light. It is called LED, light emitting diode. Junction diode, as I told, PN junction. When P type and N type are mixed, it is called PN junction. Now P type connected to positive, N connected to negative makes forward biased. When P connected to negative, N connected to positive makes reverse bias. This is forward biasing and this is reverse biasing. Both are biasing states. Now the thickness of the depletion layer. You can see depletion layer. Here this layer, it is also called depletion layer. Depletion layer thickness is of the order of 10 raised to minus 6 meter. The depletion layer width is of the order of 10 raised to minus 6 meter. Okay, now the depletion, the knee voltage is the forward voltage at which the current through the junction starts increasing rapidly. What is knee voltage? When you take a graph of the voltage versus current. Now at some stage the current is 0, even voltage is increasing. But at one particular voltage the current starts increasing rapidly. At what voltage the current increases rapidly? It is what? This voltage is called knee voltage. At what voltage the current increases rapidly is called as what? Knee voltage. Next one. Okay, next one. Next thing. Next, the transistors. Okay, the transistors, they are nothing but transistor consists of two PN junctions. Transistors are three terminal devices. I think you have not gone through the transistors, but still I will explain transistor in brief. Transistors are three terminal devices. Transistors are three terminal devices. So they are having two PN junctions, one after the other. There are two PN junctions, one after the other. So there are two types of transistors, PNP transistor and NPN transistor. NPN transistor and PNP transistor. Now there are three regions: emitter, base, collector. Three terminals means three regions: emitter, base, collector. Emitter is emitting electrons, base acts as a controller, collector collects the electrons or charge carriers. Not say electron, charge carriers. Emitter emits charge carriers, base controls the charge carriers, electrons accepts the charge carriers. Emitter is highly doped, base is least doped, collector is moderately doped. And the doping ಒಳಗ ಎಮಿಟರ್ ಭಾಳ ಹೈಲಿ ಡೋಪ್ ಮಾಡ್ತಾರೆ, ಕಲೆಕ್ಟರ್ ಮೀಡಿಯಮ್ ಆಗಿ ಡೋಪ್ ಮಾಡ್ತಾರೆ, ಬೇಸು ಅಗದಿ ಕಡಿಮೆ ಡೋಪಿಂಗ್ ಇರುತ್ತೆ. ಸೈಜ್ ನೋಡ್ಬೋದು, ಎಮಿಟರ್ ಈಸ್ moderate in size, base is least in size, collector is highest in size. About the size, collector is more, emitter is medium, base is least. That's why here you can see base is the controller. Base is what? Is a controller. In NPN transistor, electrons are the majority charge carriers because N, emitter becomes N, base becomes P and collector becomes N. That is NPN transistor. NPN means N. Electrons will move from emitter to base, base to collector. Here emitter current IE is equal to base current IB plus collector current IC. IE equal to IB plus IC. This equation you must know. IE means emitter current, IB means base current, IC means collector current. Since IB is very small, IB is very small, that's why IE is almost nearly equal to IC. In PNP transistors, holes acts as a majority charge carriers. So holes will move from in PNP. In PNP, holes move from emitter to base, base to collector. Okay. So next one, symbols of transistor. PNP transistor symbol is like this. NPN transistor is like this. So you can see PNP, the current flows from E to B, B to C, arrow mark, because holes move from E to B, B to C. Holes are positive, holes means positive, current is also along positive. But in NPN transistor, the electrons move from emitter to base and then collector. In NPN transistor, electrons move from emitter to base and collector. But the arrow mark is away from the base to away from emitter. It indicates what? Electrons are negative charges. If electron moves from emitter to base, current is taken from base to emitter, because electrons current is taken opposite. So next in normal transistor operation, emitter base junction is forward bias, collector base junction is reverse bias. If you take any emitter, base and collector, either NPN or PNP, emitter base junction is forward biased, and collector base junction is reverse biased. Emitter base junction is forward biased, collector base junction is reverse biased. Configurations of transistor. CE means common emitter. CB means common base. CC means common collector. These are the three configurations. You can go for CE mode, CB mode or CC mode. Common emitter mode, common base mode and common collector mode. The relation between beta and alpha, current gains. The beta and alpha. Beta, you have to remember these two formulas. Beta equal to alpha by 1 minus alpha, or alpha equal to beta by 1 plus beta. They are called current gains, alpha and beta. Next one. Okay, next I'll go for the questions. First question. So start with the first question. I will read the question first. The material such as conductors, insulators and semiconductors distinguished from one another on which basis? On which base you can differentiate these three materials? So very simple question. These three can be differentiated on which basis? You can see options as free electron theory of metals, band theory of metals, or kinetic theory of metals. So which is the answer? That is band theory of metasolids. So using band theory of solids, you can differentiate the metals from the materials, conductors, insulators, semiconductors on band theory of solids. Okay. So next question. I'll move to the next question. Okay, next question. Next question. I'll read the question. The energy bands which are completely filled at zero temperature called. The energy bands which are completely filled at absolute zero temperature is what? Valency band. So why? the energy bands which are completely filled. You can see conduction band is completely zero at absolute zero temperature. No forbidden bands. Forbidden bands no contains in, they doesn't contain any electrons. Intrinsic bonds are also not available. So answer is what? Valency band. Valency band is having completely filled electrons at 0 Kelvin. Next one. So next question, third question. When the energy gap is zero, the material is when the energy gap is zero, Eg is zero, the material is Eg, forbidden energy gap or energy gap zero. It indicates what? The material is a conductor. It is not inductor. It's not semiconductor. It's not dielectric. It is what? A conductor. Okay. So next question. Fermi energy level. What is Fermi energy level? Fermi energy level means it is the maximum energy of free electrons at 0 Kelvin. So what is option? Third option. Fermi energy level means what? It is the maximum energy of free electrons at 0 Kelvin. It is the maximum energy of free electrons at 0 Kelvin. So next question, fifth one. What is the fifth question? Fifth question is, at 0 Kelvin temperature, p-type semiconductor. So if you take 0 Kelvin temperature, what about the p-type semiconductor? It doesn't have any charge carriers. Options I will read. Doesn't have any charge carriers, has a few holes and a few free electrons, has a few holes but no free electrons, has a few electrons but no free holes. So option is third one. As I told, p-type at 0 Kelvin, it is having only few holes because of the doping. Dope ಮಾಡೋದ್ರಿಂದ holes ಇರುತ್ತಾವೆ ಸ್ವಲ್ಪ, but no free electrons because no breaking of bonds. Okay, at 0 Kelvin temperature, p-type semiconductor has few holes but no free electrons. Okay. So next question, sixth one. The conductivity of an intrinsic semiconductor. What about the conductivity of an intrinsic semiconductor at absolute zero? The conductivity of an intrinsic semiconductor at absolute zero is, so you can see conductivity of intrinsic semiconductor. Intrinsic semiconductor at which temperature? Absolute zero. It is what? Zero, because no conductivity is there. No conductivity. Sorry, it has gone to section. So conductivity of an intrinsic semiconductor at absolute zero is what? Zero. So next question. We'll move to next question. Seventh one. The band diagrams of three conductors are given in the following figure from left to right. They are respectively. See here. In first diagram, conduction band, valency band and forbidden energy gap is nearest to conduction band. In second one, conduction band and valency band and the forbidden energy gap is middle. In third time, conduction band and for valency band, the forbidden energy gap is nearest to valency band. If forbidden energy gap is nearest to conductor, it is n-type. If forbidden energy gap is not near to conductor, not near to valency band, it is what? Simply intrinsic semiconductor. If forbidden energy gap is nearest to valency band, it is what? P-type. So what is the answer? NIP. N-type, intrinsic, P-type means first answer is correct answer. Andre ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, dear students, you have to remember, if forbidden energy gap is nearest to conductor, it is n-type. If forbidden energy gap is middle of the conduction band and valency band, it is intrinsic semiconductor. And if forbidden energy gap is nearer to p-type, it is what? So if it is nearer to valency band, it is p-type. So answer is first one. Next question. ninth one. It is eighth one is skipped. Now I will go for ninth one. In half-wave rectifier, the RMS value of an AC component wave is. So if you take either a half-wave rectifier or a full-wave rectifier, half-wave rectifier, half portion is converted into DC. Full-wave rectifier, both cycles, negative as well as positive, both cycles are converted into DC. It is what? Full wave, and only half cycle converted means half wave. Either you take a half wave rectifier or full wave rectifier, the AC component value will be, is it more than or equal to or less than or 0? Sorry, okay. So in half wave rectifier, the RMS value of AC component is either equal to DC or more than DC or less than DC or 0. It is more than DC, means AC value will be more than DC value. As you take any charger, you take a mobile charger. Mobile charge ಮಾಡೋತ್ನಾಗ ನಾವು ಪ್ಲಗ್ ನಿಂದ AC ತಗೋತೀವಿ. AC ಏನಾಗುತ್ತೆ, ರೆಡ್ಯೂಸ್ ಆಗಿ DC ಆಗಿ ಚಾರ್ಜರ್ಗೆ ಬರುತ್ತೆ, ಮೊಬೈಲ್ಗೆ ಬರುತ್ತೆ. ಅಂದರೆ ಏನಾಗುತ್ತೆ, AC ಈಸ್ ಮೋರ್ ದ್ಯಾನ್ DC. ಚಾರ್ಜ್ ಮಾಡೋತ್ನಾಗ ಏನು ಮಾಡ್ತೀವಿ, ನಾವು AC ತಗೋತೀವಿ ಚಾರ್ಜ್ ಮಾಡಲಿಕ್ಕೆ. AC ತೊಗೊಂಡು ಅದನ್ನು DCಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿ ಮೊಬೈಲ್ಗೆ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವಿ. ಮೊಬೈಲ್ ಏನಾಗುತ್ತೆ, ಚಾರ್ಜ್ ಆಗುತ್ತೆ, ಬ್ಯಾಟ್ರಿ ಚಾರ್ಜ್ ಆಗುತ್ತೆ. ಹಾಗಾದ್ರೆ AC ಏನಾಗುತ್ತೆ, ರೆಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಹಾಗಾದ್ರೆ AC ಈಸ್ ವಾಟ್, ಲೆಸ್ ದ್ಯಾನ್, ಸಾರಿ ಮೋರ್ ದ್ಯಾನ್ DC. AC ಕಡಿಮೆ ಆಗಿರುತ್ತೆ, DC ಅಂದರೆ DC ಕಡಿಮೆ ಆಗಿರುತ್ತೆ. ಸೊ AC ಈಸ್ ಮೋರ್ ದ್ಯಾನ್ DC. Next one, 10th question. Transistors are essentially power driven devices, current driven devices, voltage driven devices, resistance driven devices. They are called current driven devices. Transistors are what? Current driven devices. ಇಲ್ಲಿ ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಏನಾಗುತ್ತೆ ಅಂತಂದರೆ, you take a PNP or NPN transistor. PNP or NPN transistor, current moves from low resistance region to high resistance region. The current moves from low resistance region to high resistance region. ಅದಕ್ಕೆ ಏನಂತಾರೆ, ಟ್ರಾನ್ಸ್ಫರ್ ಆಫ್ current from low resistance to high resistance region. Okay. So it is current driven device. Next question. Okay, let me stop now. We'll continue in the next. Okay, welcome back students. I will continue with the questions on semiconductors. I have completed 10 questions now. Now I will go for the 11th question. The 11th question is, I will read the question first. For a transistor, the value of alpha is given. The value of alpha is given. You are asked to calculate the beta value. So we know that the beta formula is, I will write the beta formula. Okay, write the formula beta. Beta equal to, we know that beta equal to alpha divided by 1 minus alpha. Beta equal to alpha divided by 1 minus alpha. Alpha is given as 0.9 divided by 1 minus 0.9. So it will be 0.9 divided by 1 minus 0.9 means it is 0.1. 0.9 by 0.1 means 9. So what is the option? Fourth one. So the value of beta is 9th one. Now okay. 9 D option is, beta value is 9 and option 4. Next, 12th question. The correct curve between potential and distance D near the PN junction is. Okay. So if you take a PN junction, so sorry, we have to go on. Okay, I will draw here once again. PN junction. So PN junction, P, and this is depletion layer, and this is N. If you take a PN junction, in this depletion layer, here it is a negative potential and this is positive potential. So because positive charges will be here electrons and negative charges will be at P side. Okay, here negative charges, here positive layers, positive layer. Okay, now potential at the middle is 0. Potential at the middle is 0. And negative 2, if you move towards the junction, here they said towards the distance d. If you move towards the junction, the negative goes to 0 and positive comes to 0. Means the potential is 0. Which graph is correctly indicating potential middle 0 is? It is not 1, it is not 2, but 3 and 4 may be possible. 3 and 4 have 0 potential at center. Means but here the potential from here it is constant, on p side it is constant and also on n side it is constant. And the p side constant irutte, n side potential constant irutte, but negative illi p side ninda junction olaga move ಆದರೆ negative will goes to 0, positive will also goes to 0, but p ದಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ, n ನಲ್ಲೂ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ. ಆಗ ಆಪ್ಷನ್ ಯಾವುದಾಗುತ್ತೆ ಹೇಳ್ರಿ? ಫೋರ್ತ್ ಒನ್. p ದಿಂದ ಈ ಜಂಕ್ಷನ್ ಬರ್ತಾನೂ ಕಾನ್ಸ್ಟೆಂಟ್, ಜಂಕ್ಷನ್ನಿಂದ ನೆಗೆಟಿವ್ ಏನಾಗುತ್ತೆ? ಜಂಕ್ಷನ್ನಿಂದ ನೆಗೆಟಿವ್ ಗೋಸ್ ಟು 0. ಇನ್ನು ಎನ್ ಸೈಡಲ್ಲೂ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ. ಎನ್ನಿಂದ ಜಂಕ್ಷನ್ ಬಂದರೆ ಜಂಕ್ಷನ್ನಿಂದ ಸೆಂಟ್ರ್ ಹೋದರೆ ಏನಾಗುತ್ತೆ? 0 ಹೋಗುತ್ತೆ, ಅಪ್ರೋಚ್ ಆಗುತ್ತೆ. ಹಾಗಾದ್ರೆ ಪಾಸಿಟಿವ್ ಟು 0, ನೆಗೆಟಿವ್ ಟು 0 ಅನ್ನೋ ಆಪ್ಷನ್ ಯಾವುದಾಗುತ್ತೆ ಹೇಳ್ರಿ? ದಟ್ ಈಸ್ ಫೋರ್ತ್ ಒನ್. ಸೊ ಫೋರ್ತ್ ಒನ್ ಈಸ್ ದ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. ಆ್ಯಂಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಸಿಲೇಟರ್ ಈಸ್ ಅ ಡಿವೈಸ್. And frequency oscillator is a device which converts DC energy into AC energy. Frequency oscillator ಒಳಗೆ ಹೆಂಗೆ rectification ಒಳಗೆ AC converts to DC, but ಇಲ್ಲಿ frequency oscillator ಒಳಗೆ DC is converted into AC. DC is converted into AC. Okay, so next question. I will go for next question. 14. A 7 segment display unit is in calculators, watches. Very simple. In calculators and watches, LEDs are used. So option E is LED. Okay, so next question. 15. The ratio of electron and hole currents, the ratio of electrons and hole currents, number of hole currents, it is in a semiconductor is 5/4. The ratio of drift velocities of electron and holes 7/4. Then the ratio of concentration of electrons and holes, concentration of electrons and holes. So ನಮ್ಗೆ ಗೊತ್ತಿರಲಿ, we know that current I equal to NEA into V. So ಹಾಗಾದ್ರೆ ಕರೆಂಟು related to N directly, related to V directly. ಹಾಗಾದ್ರೆ I proportional to NE. ಹಾಗಾದ್ರೆ IE divided by IH equal to NE into VE divided by NH into VH. And ನಮಗೆ ಏನು ಬೇಕು? ದ ರೇಷಿಯೋ ಆಫ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆ್ಯಂಡ್ ಹೋಲ್ಸ್. ಹಾಗಾದ್ರೆ IE by IH ಕೊಟ್ಟಿದ್ದಾರೆ ಕರೆಂಟ್ಸ್ 5/4. NE by NH ಕೇಳಿದ್ದಾರೆ, NE by NH ಆಸ್ಕ್ಡ್, NE by NH into VE by VH velocities ಕೊಟ್ಟಿದ್ದಾರೆ, ರೇಷಿಯೋ ಆಫ್ ವೆಲಾಸಿಟೀಸ್ 7/4. ಹಾಗಾದರೆ NE by NH ಏನಾಗುತ್ತೆ? 4 ಕ್ಯಾನ್ಸಲ್ಸ್. ಸೊ NE divided by NH equal to 5/7. ಸೊ ಆಪ್ಷನ್ ಏನಾಗುತ್ತೆ ಹೇಳ್ರಿ? 1 is the correct option. So ಇದು using current equal to NEA into VD drift velocity, NEA into VD ಈ ರೀತಿ. ಸೊ I proportional to NE. So next question ನೋಡಿ. Next question, the energy of photon, 16th one. The energy of photon of a sodium light is given. The energy of photon of a sodium light is given. That is 5890 angstrom minute. Equals to the band gap. Equals the band gap of semiconducting material. The minimum energy required to create an electron hole pair is. So minimum energy E equal to, we know that E equal to hc by lambda. So E equal to hc by lambda. Now E is asked, H is, you know that H is 6.64 into 10 raised to minus 34 into what is E, what is C? 3 into 10 raised to 8 divided by lambda. 5890 into 10 raised to minus 10. After doing calculations, you get it is answer as 2.1 EV. 2.1 EV. That is option number 1. Okay, so next question. Which of the following semiconductor diode is a reverse bias? Reverse bias. What is reverse bias? Reverse bias, P and N junction. P connected to negative, N connected to positive. It is what? Reverse bias. P connected to negative, N connected to positive. So in the diagram, you can see diode 10 volt positive, 5 volt negative. 10 volt positive, it means more forward biased, it is also forward biased. This one 10 connected to positive, ಇದು triangle shape positive idange, P type idange, ಇದು N type. P connected to 10 volt means again positive, means it is forward bias. Here P connected to negative, and here N also connected to negative but more voltage. Agar this also N connected to negative means is also forward bias. So which is reverse bias here? This one. Negative connected to this P type. Negative connected to P type means reverse bias. This is only the reverse bias. Option is 1. Okay. So next question. In the figure given below, the potential difference between A and B is. The potential difference between A and B is. Very simple, no need to. It is diode is forward biased, so current flows. Diode is forward biased, current flows. So just take a resistance. What about the stem resistance? 10 and 10. 10 and 10 means 10 and 10 parallel. 10 and 10 parallel means 5. But series 10 plus 10 20. But 10 and 10 parallel means 5 kilo ohm. When it is connected to this is 5 kilo ohm and this is 10 kilo ohm, means voltage is distributed to one is 10 and other is 5. How the total voltage, how much it is total voltage? Here you can see 30 voltage. 30 voltage falls to 10 and 5, means 30, if you divide these two, 30 volt goes to, out of 30 volt, nearly 10 volts goes to 5 kilo ohm, and remaining 20 volt goes to 10 kilo ohm. Means what is the answer here? 10 volt. So ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಇದು 10 ಕಿಲೋ ಓಮ್ಗೆ ಈ ಟೋಟಲ್ ಕಾಂಬಿನೇಷನ್ 5 ಕಿಲೋ ಓಮ್ಗೆ ಎಷ್ಟು ಡಿವೈಡ್ ಆಯಿತು? 10ಗೆ ರೇಷಿಯೋ ಎಷ್ಟಾಯ್ತು? 10/5. 10/5 ಅಂದರೆ 2:1. 2:1 ಅಂದರೆ ಇದರಲ್ಲಿ 2 ಪಟ್ಟು, ಇದರಲ್ಲಿ 1 ಪಟ್ಟು, ಅಂದರೆ ಟೋಟಲ್ 3 ಪಟ್ಟು. 2 ಪಟ್ಟು ಅಂದರೆ 20 ವೋಲ್ಟ್, 1 ಪಟ್ಟು ಅಂದರೆ 10 ವೋಲ್ಟ್. ಹಾಗಾದರೆ 10 ವೋಲ್ಟ್ ಎಲ್ಲಿ ಹೋಗುತ್ತೆ? ಈ ಎ ಬಿ ಪಾರ್ಟಿಗೆ ಹೋಗುತ್ತೆ. ಸೊ ಆನ್ಸರ್ ಏನು? 10 ವೋಲ್ಟ್. ಓಕೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್, ಡಿಜಿಟಲ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ನೆಕ್ಸ್ಟ್ ಐ ವಿಲ್ ಗೋ ಫಾರ್ ಡಿಜಿಟಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್. ಡಿಜಿಟಲ್ ಎಲೆಕ್ಟ್ರಾನ್ಸಲ್ಲಿ ಲಾಜಿಕ್ ಗೇಟ್ಸ್ ಇರ್ತವೆ. You can see logic gates. In this table I have entirely written about all the gates. A and B inputs, these are called inputs. AND gate, NAND gate, OR gate, NOR gate, exclusive OR gate, XOR gate. And I will go for next slide. Formulas for the formulas are given. Okay, next I will go for next slide. In this formulas are given. You can see here AND gate in every A dot B, AND gate A dot B, OR gate A plus B, NOT gate A bar or B bar, NAND gate A dot B bar, NOR gate A plus B bar, exclusive OR gate A plus of B. ಹೆಂಗೆ ಬರ್ತಾರೆ ಗೊತ್ತಾ? ಸೊ A B bar plus B A bar B. So this is exclusive OR gate, A B bar plus A bar B. In A dot of plus B means it is A B plus A bar B bar, A bar B bar. This is a formula for exclusive OR gate. With this formulas and truth table, I will go for next questions. A logic gate is an electronic circuit which makes options sorting. Makes logical decisions. Simple answer. Logical additions. Logic gates does logical decisions. Second ನೋಡಿ allows electrons to flow one in direction, alternates between 1 and 0 and volt, allows only whole few flow to flow one direction. No, correct option is what? Logic decisions. Digital electrons makes logic decisions. Okay, so next question, second one. Given below are 4 logic gates. The symbols of OR, NOR and NAND are. OR symbol is the third one, sorry, not third one, sorry, first one. OR symbol is first one. NOR symbol is, NOR means this is a symbol of NOR means 3, and NAND symbol is this is 2. So you can see OR symbol is 1, NOR symbol is 3, and NAND symbol is 2, means 1 3 2. 1 3 2 means option C is correct. Okay, so next question. The combination of NAND gates shown are equivalent to which logic gate symbols shown here. This is the circuit diagram given below. Now on this basis we have to make the decision. ಇದರ ಮೇಲೆ ಯಾವ ಗೇಟ್ ಬರುತ್ತೆ, ಒಂದನೇದು ಯಾವ ಗೇಟ್ ಆಗುತ್ತೆ, ಎರಡನೇದು ಯಾವ ಗೇಟ್ ಆಗುತ್ತೆ, ನಾವು ಡಿಸಿಷನ್ ಮಾಡಬೇಕು. ಒಂದನೇದು ನೋಡಿ, ಒಂದನೇದು ಏನಾಗುತ್ತೆ ಅಂದರೆ ಇಲ್ಲಿ ನಾವು ತೋರಿಸುತ್ತೆ ನೋಡ್ರಿ, ಇಲ್ಲಿ ಒಂದನೇದು ಅಲ್ಟಿಮೇಟ್ಲಿ ಸಿ ಈಕ್ವಲ್ ಟು, ಸೊ ಸಿ ಈಕ್ವಲ್ ಟು ಏನಾಗುತ್ತೆ ಗೊತ್ತಾ, ಸಿ ಈಕ್ವಲ್ ಟು ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ನೋಡಿದೆ ಎ ಬಾರ್, ಎರಡು ಕೂಡಿಸೇ ಇರುತ್ತೆ. ಹಾಗಾದ್ರೆ ಇದು ಎ ಬಾರ್, ಎ ಬಾರ್, ಇದೇನು ಬಿ ಬಾರ್, ಇದು ಬಿ, ಇದು ಎ ಬಾರ್, ಯಾಕಂದ್ರೆ ನ್ಯಾಂಡ್ ಗೇಟ್ ಇದೆ, ಎ ಬಾರ್ ಡಾಟ್ ಬಿ ಬಾರ್ ಆ್ಯಂಡ್ ಬಾರ್, ಎ ಬಾರ್ ಡಾಟ್ ಬಿ ಬಾರ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಎ ಬಾರ್ ಡಾಟ್ ಬಿ ಬಾರ್ ಏನಾಗುತ್ತೆ ಹೇಳ್ರಿ, ಎ ಡಬಲ್ ಬಾರ್ ಬಿ ಬಾರ್ ಡಾಟ್ ಏನಾಗುತ್ತೆ ಬಿ ಡಬಲ್ ಬಾರ್ ಪ್ಲಸ್. ಸೊ ಟೋಟಲಿ ಇದು ಆನ್ಸರ್ ಏನಾಗುತ್ತೆ ಹೇಳಿ, ಸಿಯರ್ ಎ ಬಾರ್ ಡಾಟ್ ಬಿ ಬಾರ್ ಈಕ್ವಲ್ ಟು ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಹೇಳಿ, ಮತ್ತೆ ಆ್ಯಂಡ್ ಗೇಟ್ ಇದೆ. ಸೊ ಎ ಡಬಲ್ ಬಾರ್ ಬಿ ಡಬಲ್ ಬಾರ್, ಎ ಡಬಲ್ ಬಾರ್ ಬಿ ಡಬಲ್ ಬಾರ್ ಅಂದರೆ ಏನಾಗುತ್ತೆ ಹೇಳಿ ಆನ್ಸರ್ ಎ ಪ್ಲಸ್ ಬಿ, ಎ ಪ್ಲಸ್ ಬಿ, ಎ ಪ್ಲಸ್ ಬಿ, ಎ ಪ್ಲಸ್ ಬಿ ಅಂದರೆ ಏನಾಗುತ್ತೆ ಹೇಳಿ ಆರ್ ಗೇಟ್. ಹಾಗಾದ್ರೆ ಒಂದನೇದು ಏನಾಗುತ್ತೆ ಹೇಳಿ ಆರ್ ಗೇಟ್. ಎರಡನೇದು ಏನಾಗುತ್ತೆ ನೋಡಿ, ಸೆಕೆಂಡ್ ಒನ್ ಇಲ್ಲಿ ನೋಡಿದೆ ಎ ಸಿ ಈಕ್ವಲ್ ಟು ಎ ಡಾಟ್ ಬಿ ಡಬಲ್ ಬಾರ್, ಎ ಡಾಟ್ ಬಿ ಡಬಲ್ ಬಾರ್. ಹಾಗಾದ್ರೆ ಟೋಟಲಿ ಏನಾಗುತ್ತೆ ಹೇಳಿದ್ದು ಎ ಡಬಲ್ ಡಾಟ್ ಬಿ ಬಾರ್ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ ಇದು ಆ್ಯಂಡ್ ಗೇಟ್. ಸೊ ಆ್ಯಂಡ್ ಗೇಟ್ ಏನಾಗುತ್ತೆ ಹೇಳ್ರಿ, ಫಸ್ಟ್ ಆಪ್ಷನ್ ಆರ್ ಗೇಟ್ ಆ್ಯಂಡ್ ದಿಸ್ ಈಸ್ ಆ್ಯಂಡ್ ಗೇಟ್. ಇಟ್ ವಿಲ್ ಬಿಕಮ್ ಎ ಡಾಟ್ ಬಿ, ಎ ಡಾಟ್ ಬಿ ಇಂದ ಏನಾಗುತ್ತೆ ಹೇಳ್ರಿ ಆ್ಯಂಡ್ ಗೇಟ್. ಸೊ ಅದರ ಆಪ್ಷನ್ ಏನು ಹೇಳ್ರಿ, ಒಂದನೇದು ಎ ಪ್ಲಸ್ ಬಿ ಆಗುತ್ತೆ, ಎರಡನೇದು ಎ ಡಾಟ್ ಬಿ ಆಗುತ್ತೆ. ಒಂದನೇದು ಎ ಪ್ಲಸ್ ಬಿ ಅಂದರೆ ಇದು ಎ ಪ್ಲಸ್ ಬಿ ಬರುತ್ತೆ, ಇದೇನಾಗುತ್ತೆ ಎ ಡಾಟ್ ಬಿ ಆಗುತ್ತೆ. ಎ ಪ್ಲಸ್ ಬಿ ಅಂದರೆ ಆರ್ ಗೇಟು, ಎ ಡಾಟ್ ಬಿ ಅಂದರೆ ಆ್ಯಂಡ್ ಗೇಟು. ಸೊ ಫಸ್ಟ್ ಆಪ್ಷನ್ ಈಸ್ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್. ಓಕೆ, ಸೊ ಫೋರ್ತ್ ಕ್ವಶನ್, ವಿಚ್ ಆಫ್ ದ ಫಾಲೋಯಿಂಗ್ ವಿಲ್ ಹ್ಯಾವ್ ಆ್ಯನ್ ಔಟ್ಪುಟ್ ಆಫ್ 1? ಯಾವುದು ಇಲ್ಲಿ ಔಟ್ಪುಟ್ 1 ಆಗುತ್ತೆ ನೋಡಿ, ಚೆಕ್ ಮಾಡೋಣ. ಸೊ ಲೆಟ್ ಅಸ್ ಚೆಕ್ ವಿಚ್ ವಿಲ್ ಬಿ ದ ಔಟ್ಪುಟ್ 1. ನೋಡಿ ಇದು 1 ಡಾಟ್ 1 ಏನಾಗುತ್ತೆ ಹೇಳಿ 1.1. ಸೊ ಏನಾಗುತ್ತೆ 1.1 ಅದು ಬಾರ್, 1.1 ಬಾರ್ ಏನಾಗುತ್ತೆ 1.1 ಬಾರ್ ಏನಾಗುತ್ತೆ ಹೇಳಿ 0. ಹಾಗಾದರೆ ಏನಾಗುತ್ತೆ ಫಸ್ಟ್ ಒನ್ ನಾಟ್ ಪಾಸಿಬಲ್. 1.1 ಬಾರ್, 1.1 ಬಾರ್ ಅಂದೇನೆ 1.1 ಬಾರ್ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ 0. ಸೊ ಇದು ಆಗಲ್ಲ. ನೆಕ್ಸ್ಟ್ ಒನ್ 0.1 0.1 ಬಾರ್, 0.1 ಬಾರ್ ಏನಾಗುತ್ತೆ 0 ಬಾರ್, 0 ಬಾರ್ ಏನಾಗುತ್ತೆ 1. ಸೊ ಹಾಗಾದ್ರೆ ಯಾವ್ದು ಕರೆಕ್ಟ್ ಆಗುತ್ತೆ ಸೆಕೆಂಡ್ ಒನ್. ಚೆಕ್ ಅದ ಥರ್ಡ್ ಆ್ಯಂಡ್ ಫೋರ್ತ್ ಅವನು ಚೆಕ್ ಮಾಡೋಣ. ಇದೇನಾಗುತ್ತೆ 0.1 ಇದು ಆರ್ ಗೇಟ್, ಅದು ನಾರ್ ಗೇಟ್ ಇದು ನ್ಯಾಂಡ್ ಗೇಟ್ ಇವೆರಡು, ಇದು ನಾರ್ ಗೇಟ್ ಎಂದು ಏನಾಗುತ್ತೆ 0 ಪ್ಲಸ್ 0 ಬಾರ್, 0 ಪ್ಲಸ್ 0 ಬಾರ್ ಏನಾಗುತ್ತೆ 0 ಬಾರ್ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ 0 ಆ್ಯಂಡ್ 1 ಇದೆ, ನಾಟ್ 0 ಪ್ಲಸ್ 1, 0 ಪ್ಲಸ್ 1 ಏನು 1 ಬಾರ್ ಏನಾಗುತ್ತೆ 0. ಇದು 0. ಇದು ಎಕ್ಸ್ಕ್ಲೂಸಿವ್ ಆರ್ ಗೇಟ್. ಎರಡು ಎಕ್ಸ್ಕ್ಲೂಸಿವ್ ಆರ್ ಗೇಟಲ್ಲಿ ಆರ್ ಗೇಟ್ ಇದು ಎಕ್ಸ್ಕ್ಲೂಸಿವ್ ಆರ್ ಗೇಟಲ್ಲಿ ಎರಡೂ 0 0 ಇದ್ದಾಗ ಆಪ್ಷನ್ ಏನಾಗುತ್ತೆ ಹೇಳಿ 0 ಬರುತ್ತೆ ಇದು. ಸೊ ಆಪ್ಷನ್ ಏನಾಗುತ್ತೆ ಹೇಳ್ರಿ, ಸೆಕೆಂಡ್ ಒನ್ ಈಸ್ ಕರೆಕ್ಟ್, ಔಟ್ಪುಟ್ 1. Next question. For given combination of gates, if the logic gates of inputs A, B, C are given as follows: A equal to B equal to C equal to 0 and A equal to B equal to 1 and C equal to 0, then logic gates of the output are. ಈಗ ನೋಡಿ ಫಸ್ಟ್ A B C 0 ತಗೊಳ್ಳೋಣ. A 0 B 0 C 0. ಇಲ್ಲಿ 0 ಪ್ಲಸ್ 0 ಇದು ಆರ್ ಗೇಟ್, ಇದು 0 ಪ್ಲಸ್ 0 0. ಇಲ್ಲಿ ಬರೋಣ, ಇಲ್ಲಿ 0 ಬಂತು, ಇಲ್ಲಿ ಇದು 0 ಬಂತು. ಇದು ನ್ಯಾಂಡ್ ಗೇಟ್ ಅಂದರೆ ಏನಾಗ್ತೈತೆ, ಇದು 0 ಪ್ಲಸ್ 0 ಪ್ಲಸ್ ಸಾರಿ 0 ಡಾಟ್ ನಾಟ್ ಪ್ಲಸ್ 0 ಡಾಟ್ 0 ಡಾಟ್ 0 ಬಾರ್ 0 ಡಾಟ್ 0 ಬಾರ್ ಅಂದರೆ 0 ಬಾರ್ 0 ಬಾರ್ ಅಂದರೆ 1. ಹಾಗಾದರೆ ಒಂದೇದೇನು 1 ಯಾವಾಗ ಇಫ್ ಆಲ್ ಆರ್ ಜೀರೋಸ್. ನೆಕ್ಸ್ಟ್ A ಈಕ್ವಲ್ ಟು 1 B ಈಕ್ವಲ್ ಟು 1 C ಈಕ್ವಲ್ ಟು 0. A ಈಕ್ವಲ್ ಟು 1 ಆ್ಯಂಡ್ B ಈಕ್ವಲ್ ಟು 1 ಅಂದರೆ ಏನಾಗುತ್ತೆ ಹೇಳಿ 1 ಪ್ಲಸ್ 1 ಏನಾಗುತ್ತೆ ಹೇಳಿ 1. ಇಲ್ಲಂತೂ 0, ಎರಡನೇದೇನಿದು C 0. ಹಾಗಾದ್ರೆ ಇವೆರಡು ಕೂಡಿ ಆ್ಯಂಡ್ ಗೇಟ್ ಬರ್ತವೆ. ಆ್ಯಂಡ್ ಗೇಟ್ ಅಂದರೆ ಏನಾಗುತ್ತೆ 1 ಡಾಟ್ 0 ಬಾರ್ 1 ಡಾಟ್ 0 ಬಾರ್ ಏನಾಗುತ್ತೆ 1 ಡಾಟ್ 0 ಬಾರ್ ಅಂದರೆ ಏನಾಗುತ್ತೆ ಹೇಳಿ 1. ಹಾಗಾದ್ರೆ ಎರಡು ಏನು 1 ಆ್ಯಂಡ್ 1 ಇರುವಂಥ ಆಪ್ಷನ್ ಯಾವುದು, ಥರ್ಡ್ ಒನ್. ಸೊ ಆಪ್ಷನ್ ವಿಚ್ ಒನ್ ಈಸ್ ಕರೆಕ್ಟ್, ಥರ್ಡ್ ಒನ್ ಈಸ್ ಕರೆಕ್ಟ್. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. Digital circuits can be made by respective use of NAND gates, because NAND gate is a universal gate. So that's why digital circuits can be made using NAND gates because of universal gate. So with this I'll continue in the next class. Welcome back students. In this video I'm going to discuss the additional questions on semiconductors and digital electronics. Okay, once again I will repeat. In this video I am going to discuss the extra questions on semiconductors and digital electronics. Okay, look at the screen. So first question on semiconductors. The majority charge carriers in p-type semiconductors are very simple. Majority charge carriers in p-type, the electrons, protons, holes and neutrons. So the answer is holes. Okay, so holes is the correct option. Very simple question, simple answer. Okay, next question. A p-type semiconductor can be obtained by adding. How to obtain a p-type semiconductor? P-type semiconductor is obtained by adding an impurity which is a trivalent impurity. The trivalent impurities are gallium. Gallium is what? A trivalent impurity to pure silicon. So arsenic, antimony, phosphorus are pentavalent. So trivalent is gallium. Okay. So next question. Third one. The valency of an impurity added to germanium crystal in order to convert it into p-type semiconductor is, the valency of the impurity atom should be trivalent. Trivalent means 3. To get p-type we have to get a trivalent impurity, that is 3 valency electrons. Option D. Okay, so next move to the next question. Fourth question I am going to discuss. Fourth question. Fourth question. In a semiconductor, the concentrations of electrons is 8 into 10 raised to 14 per centimeter cube, and that of holes is 5 into 10 raised to 12 per centimeter cube. Then the semiconductor is, so here concentrations of electrons is more compared to what? Holes. If the electrons are more compared to holes, then it is called a n-type semiconductor, because Ne greater than Nh. Okay, so option is B. Okay, next question. In a p-type semiconductor, there is an, in a p-type semiconductor, what is there? There is an excess of electron, absence of electron, missing atom, or donor level. So the simple answer is absence of an electron, means B option. Because in p-type semiconductor there are 3 valence electrons. There is a one vacancy created, and when vacancy is created, it means there is an absence of one electron. Okay, next question, sixth question is the valency of impurity atom that is to be added to germanium crystal so as to make it n-type semiconductor is the valency of an impurity atom added to make the germanium crystal a n-type semiconductor is, we have to add a pentavalent impurity atom. Pentavalent impurity atom means, which one is the correct option? Fifth one, 5 valence electrons, that is B. B is the correct option. Okay, fifth one B, because pentavalent impurity. Okay. After this, seventh one, silicon is a semiconductor. Seventh one, silicon is a semiconductor. If a small amount of AS, that is arsenic, is added to it, if arsenic is added to it, then its electrical conductivity, what happens to the electrical conductivity of the silicon? Whether it decreases, increases, remains unchanged, or becomes zero? Very simple answer. If you add more and more impurities, arsenic is an impurity. So if you add more and more impurity to the semiconductors, its conductivity automatically increases. Means option is B. The semiconductor conductivity increases by adding the impurities. So seventh is B. Okay, eighth question. When an electrical conductivity of an semiconductor is due to breaking of its covalent bonds, then the semiconductor is said to be, okay, when the electrical conductivity of a semiconductor is due to breaking of bonds, the breaking of bonds indicates what? The electrons gets energy, so it comes out. Then the semiconductor is said to be, is it a donor, is it a acceptor, it is intrinsic or extrinsic? So we know that breaking of covalent bonds will make intrinsic semiconductor. So option 8th one is what? C. Breaking of covalent bonds means intrinsic semiconductor. So next question is ninth question. A piece of copper and other of germanium are cooled. A piece of copper and other of germanium are cooled from room temperature to 80 Kelvin. Means they are cooled, means temperature is decreased. Then which of the following would be the correct statement? Whether the resistance of both will increase, resistance of both will decrease, resistance of copper increases while that of germanium decreases, resistance of copper decreases, that of germanium increases. So copper is what? Copper is conductor. Copper is what? Conductor. Now germanium is what? Germanium is what? It is semiconductor. Germanium is a semiconductor. So it means as you decrease the temperature, conductor resistance increases, semiconductor resistance decreases, semiconductor resistance increases. It indicates that resistance of copper increases, germanium decreases. So which one would be the correct option? So when a piece of copper and germanium are cooled, means their temperature is decreased. What happens to the following correct statement? Means now copper is a conductor. When its temperature decreases, resistance decreases. When semiconductor germanium is semiconductor, when its temperature decreases, its resistance increases. Means germanium increases, copper decreases. So option is D. D is the correct option. Okay. So let us move to next question. 10th one. So 10th question. To obtain p-type semiconductor, p-type silicon semiconductor, we need to dope a pure Si with which of the following atoms? See here, as we have to get a p type, means we have to need a trivalent impurity. So which out of the following four options, which is trivalent? Either aluminum, or is it phosphorus, or oxygen, or germanium? So best option is aluminum. So aluminum is a trivalent impurity. So we have to get what? P silicon should be doped with what? Aluminum. Okay, so next question, the electrical conductivity of semiconductor. What happens to the electrical conductivity of semiconductor with temperature? The following factors are with temperature. We know that semiconductor, as the temperature of semiconductor increases, resistance will decrease, but conductivity will increase. So as temperature increases, what happens to the conductivity? Conductivity will increase and resistance will decrease. Means as the electric conductivity of semiconductor will increase it with increase of temperature. Means option is B is correct option here. Increases with its temperature. So conductivity will not decrease with temperature. It doesn't change. It is changing. First increases, next decrease not. So correct option is what? Increases with increase in temperature. Okay, next move to 12th question. Three semiconductors are arranged in increasing order of their energy gap of the follows as follows, the correct statement. So with the increasing order of energy gap, we know that there are three atoms: tellurium, germanium, and silicon. Tellurium, germanium, and silicon. So we know that increasing order, silicon is having highest forbidden energy, the energy gap. Next is germanium, next is tellurium. Means increasing order means tellurium is reached, germanium is next, next is silicon. Means we have to start from tellurium, lowest energy gap, germanium, still more energy gap, still more energy gap, highest is silicon. Means increasing order is what? A. Tellurium, germanium, and silicon. Okay, so next question, 13th question. When, okay, see here, 13th question, move to 13th question. Okay, 13th question. When a semiconductor is heated, its resistance, we know that when semiconductor is heated, temperature increases, resistance will automatically decrease. Means 13th option is A. Next question. In an insulator, the forbidden energy gap. In an insulator, the forbidden energy gap between the valency band and conduction band is of the order of. Insulators are having very high forbidden energy gap, 1 or 0.1 or 1 or 5. Highest means 5 electron volt. So 14th is 5 electron volt, because insulators are having very high forbidden energy gap between valency band and conduction band. So the insulators doesn't conduct. So highest means 5 electron volt. So next question is for 15th question. 15th question. Let us move to 15th question. Go on up. Okay, 15th question. A N-type semiconductor is it negatively charged or positively charged or neutral or none of these options? N-type, as I told, N-type means it is negative type semiconductor, means it is not negatively charged or positively charged. It is a neutral semiconductor. So option is C. 15th is C. Okay. 16th. The energy band gap of silicon is. So what is the energy gap of silicon? So energy gap of silicon is nearly 1.1 electron volt. Remember students, ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, the forbidden energy gap, I am saying about forbidden energy gap of silicon is 1.1 electron volt. So next move to next question. 17th. The forbidden energy gap between Forward energy band gap in conductors, semiconductors and insulators are Eg1, Eg2, Eg3 respectively. What is the relation between them? So Eg1 indicates forward energy gap for conductors, Eg2 semiconductors, Eg3 insulators. We know that forward energy gap for conductor is reached, medium for semiconductors, highest for insulators. Means Eg1 is less than Eg2, Eg2 is less than Eg3. So best option is this one. See here, B option, Eg1 less than Eg2 less than Eg3. So means option is B. Okay. So so move to the next question. 18th question. Which statement is correct? You have to observe the following statement. Which statement is correct? You have to get the answer. N type ಯಾವ statement correct ಇದೆ mark ಮಾಡೋದು ಅಷ್ಟೇ. You have to mark which one is the correct statement. Okay. N type germanium is negatively charged. P type is positively charged. No, not possible. This is not correct statement. Both N type and P type are neutral. Okay. P type and N type are neutral. It is correct. Definitely 18th B option is correct. And we have to look at for the other options also. N type germanium is negatively, P type is negatively charged. No, see here, this is also not correct statement because they are not charged, they are neutral. Next, both N type and P type negatively. This is also not correct. So which one is the correct option? Correct option is B. Means both P type and N type are neutral. Correct statement. Okay, next move to next slide. 19th question. 19th. When germanium crystal, see here, when germanium crystal are doped with phosphorus, germanium is doped with phosphorus atom, then it becomes, see here, germanium is a semiconductor, phosphorus is an impurity. When phosphorus is a pentavalent impurity, after adding a pentavalent impurity to germanium, we will get what? N-type semiconductors. So option is C. 19th is C. Phosphorus is what? Pentavalent impurity. So we get N-type. Next, 20th question. Let NP and NB be the number of holes and conduction electrons respectively in a semiconductor. NP means number of holes, NE means number of electrons. So which of the following statement is correct? NP is greater than NE for intrinsic, so not possible because they are equal. NP is equal to NE for extrinsic, so that is also not possible. NP is equal to NE, it is for intrinsic semiconductor, so it is correct option. So 20th correct option is C. So we have to look at for D option whether it is correct or wrong. NE is greater than NP for intrinsic, so that is also not possible. So correct option is NP equal to NE. So 20th question, 21st question. The energy gap of silicon is 1.14 eV. The maximum wavelength at which silicon will being absorbing energy. So you have to convert this energy into wavelength 1.14 eV. So we know that lambda equal to hc by E. Lambda equal to hc by E. Again we have to substitute H value. H value is what? 6.6 into 10 raised to minus 34 into C is what? 3 into 10 raised to 8 whole divided by, this is 1 point, energy is 1.14 eV. We have to convert it into joules. 1.14 into 1.6 into 10 raised to minus 19. Minus 19. Make it this as minus 19. It has gone over. So I will write minus 1 10 raised to minus 19. After doing the calculations, it is minus 19. I will write here minus 19. So after doing calculations and adjustments, you will get the answer as 10888 angstrom unit. So by doing the calculations, you will get 10888. Means option A is correct. Option A is correct. Okay, 21 is A. Okay, next 22. Which of the following energy band shows N-type semiconductor? Okay, we know that for n-type semiconductor, the forbidden energy level, impurity level should be towards conduction band. The impurity level is to be towards conduction band. So in all these four diagrams, the conduction level, see dotted line, this dotted line, it is towards conduction band, not valency band. It is towards conduction band means n-type. It is towards valency band means it is p-type. But here, see here, C is also maybe correct option, but look at the diagram, whether valency band is up or conduction band is up. So valency band is never up. Okay, so sorry. Okay. Here I'll go to 22. See here, C in C option, valency band is given up. Male torsidare. Conduction band is shown down, but never possible because conduction band is higher band, valency band is lower band. It should be up. So C is not possible. So B is correct option. Okay, 22 B. The impurity level should be towards conduction band. If impurity level is towards valency band, it is P type. It is in between intrinsic. Okay. So next question 23. The mobility of free electron is greater than that of free holes because why the mobility of free electrons is greater than that of free holes because why it is greater? The negative, they carry negative charge, they are light, they are they mutually collide less, they require low energy to continue their motion. So which is the correct option here? Here in this okay, see here, the mobility of free electrons is greater than that of holes because they carry negative charge. It is not proper reason. They are light, not proper reason. They mutually collide less. There is not. They require low energy to continue their motion. See here, mobility of free electrons is greater than that of holes means they require means holes require low energy to move, and in this way we can say that the free electrons, see a simple answer is free electrons are existing particles, holes are, they are imaginary. Holes means it is a vacancy, it is not any particle, but still we consider hole as a one charge because the vacancy created will move in possible directions. So hole is imaginary, real is what? A free electron. So free electron energy is greater than of free holes because they require low energy to continue their motion. So option is D. So they will not collide. Electron will not collide with hole. It will only take its position. Electron will take its position of hole. There is no exact collision because hole is imaginary, free electron is really. Okay. So 23 option is D. Okay. Next move to next question. 24th question. The relation between the number of free electrons in semiconductors and with its temperature is. So the relation between the free electrons and temperature is, we know that the free electrons, the relation number of free electrons, it is equal to n equal to, it is written as constant A into T raised to 3 divided by 2, 3 by 2 e raised to, it is exponential constant Eg forbidden energy gap divided by Kt. See here, this all constant, this also constant. So it indicates n is proportional to T raised to 3 by 2. So with temperature, number of free electrons is direct proportional to T raised to 3 by 2. So which is the option correct? D. D is the correct option. Okay, next move to next question. 25th. The electron mobility in n-type germanium is 3900 and its conductivity is 6.24. Then the impurity concentration will be impurity concentration. Impurity concentration means number of free electrons. We know that sigma is written as sigma, conductivity sigma, it is written as E into Ne into mobility mobility of free electrons. So we want Ne, number of free electrons, Ne. Ne equal to what? Formula will become sigma conductivity divided by E into mu E. What is sigma? Substitute. The value of sigma is already given, conductivity 6.24 whole divided by E. We know that E equal to 1.6 into 10 raised to minus 19 into, so what is mu E? It is written as mobility 3900. After doing the calculations, you will get the answer as 10 raised to 16. 10 raised to 16 per centimeter cube. So option is D. So 25th question answer is D. Okay. So next we move for the next question. 26th question. Which of the energy band diagram shown in the figure corresponds to that of semiconductor? See here, following diagrams, conduction band and valency band. So it is not shown properly. Conduction band, valency band, it's not answer. So here, for semiconductors, the forbidden energy gap is equal to Kt. Remember, the forbidden energy gap is nearly equal to what? Kt. It is almost equal to, or it is nearly equal to Kt, means the correct option is D. Okay, so remember, for semiconductors, Eg, forbidden energy gap, is nearly equal to Kt. So which is the correct option? D. Okay, next we move for the next question. 27th question. 27th question. The energy band diagrams of three semiconductors of the samples of silicon are shown. So energy gaps for silicon sample are given here. We can see that, assert that. From this we have to get the correct statement here. So correct statement. Okay, now when X is sample X, see here in sample X is undoped while Y and Z are doped with third group and fifth group impurity. So here X is undoped, very correct answer, undoped. Y is, here impurity level is towards, the impurity level is towards conduction band. If it is conduction band, you have to get this as valency band. So impurity level is towards conduction band means it is N type. If impurity level is towards valency conduction band is N type. If it is towards valency band, it is P type. It is doped with it is doped with pentavalent impurity 5. It is doped with trivalent impurity, means undoped X 5th group impurity, third group impurity. Y is 5th, Z is third group, 5th, this is third, and it is undoped. So which is the option? X is undoped, Y is third, not possible. X is undoped, Y and Z are doped 5th, not possible. X is doped, not possible. X is undoped, well samples Y and Z are doped with 5th and third group, means option D is correct. Okay, next move to next question. 28th question. Carbon, silicon, germanium atoms have 4 valency electrons. Their valency and conduction band are separated by forbidden energy gap EgC, EgI, EgSi, EgGe, germanium respectively. Which of the following relation is correct? See here, normally carbon, silicon, germanium, all are having 4 valency electrons. Okay, all are having 4 valency electrons. So here, forbidden energy gap of carbon is greater than silicon, and that of silicon is greater than germanium. Means EgC, Eg for C is greater than Eg for Si. So search this, you will get this answer. EgC is greater than EgSi, means option 28th question, option A is correct here. So forbidden energy gap of carbon is greater than that of silicon. Means EGC is greater than Si. It is not less than germanium or silicon. It is greater than germanium and silicon. Means B, A option is correct. So here germanium, carbon has got more forbidden energy gap compared to silicon and germanium. So option A is correct. So next one, a semiconductor doped with donor impurity. Donor means pentavalent. Pentavalent means N type. So simple answer B. Donor means pentavalent. Pentavalent means N type. Okay. So next question, 30th question. In a semiconducting material, the mobilities of electron and holes are mu E and mu H respectively. Which of the following is true? Mobility of electrons is greater than holes or less than holes or equal to. So correct option is mobility of electrons. As I discussed, mobility of electrons is greater than holes. Already discussed in the above question, mobility of electrons is greater than that of holes. So option A is correct. Okay. So after this, let us move to the next part of questions on semiconductor diodes. So we know that what is a diode? Diode is a PN junction device. Okay. In the forward bias arrangement of PN, question I will read the question, first question. In the forward bias arrangement of PN junction diode, so forward bias PN junction, PN. Oh, okay. In forward bias means P should be connected to positive, N should be connected to negative. P should be connected to positive terminal and N should be connected to negative terminal. So which one is the correct option? P and is connected to positive terminal. See here, N is connected to positive, not possible. Direction of current from N to P and not correct, proper answer. P and is connected to negative is not also proper answer. So option B is correct. P connected to positive terminal. So after this, next question. In a PN junction diode, the current in the reverse bias condition is, what is the correct option you have to get in this second question? In PN junction, what happens? I will read the options. The current in the reverse bias condition is generally small. Reverse bias condition current is small. It may be correct option. We'll go through other options also. It is correct about A. But now next question option. So observe madana. The current in the reverse bias condition is small, but forward bias current is independent. So there is no forward bias current in PN junction diode. In which case reverse bias. So B is not possible. So reverse bias current, C option, reverse bias current is strong dependent bias voltage. This is also not possible. So forward bias current is very small, and forward and reverse bias current is bias current comparison with reverse bias. See here, forward bias current is more compared with reverse. So D is also not possible. So better, correct and suitable answer is A. The reverse bias in reverse bias condition, the current is generally small. So second one A. Okay, third one. The cut-in voltage for silicon diode is approximately. So third question. What is the cut-in voltage for silicon? Cut-in voltage, or we also known as knee voltage, Vk for silicon is nearly from 0.6 volt. So approximately 0.6 volt. It means B is correct option. Remember, I am telling about cut-in voltage. Cut-in voltage for silicon is nearly 0.6 volt. So option B is correct, because at cut-in voltage means when you plot a graph of voltage versus current, so we know that the current rapidly increases at one stage, that is called knee voltage. This knee voltage for silicon is 0.6 volt. Okay. So next question. The electrical circuit used to get smooth DC output from rectifier circuit is called. See here. Rectifier is what? Converts AC into DC. Oscillator converts DC into AC. Oscillator converts DC into AC. Filter, okay. Amplifier amplifies. It makes strong output. Logic gates makes logic distance. So A is not possible. B, C is not possible. So D is not possible. B is the correct option. D, A, C are wrong, because A oscillator converts a DC into AC. Oscillator converts DC into AC. Amplifier increase the strength of signal. Logic gates make logical decisions. So filter circuits gets a smooth DC outputs. So option is B. Okay, next question. A PN junction diode works as insulator. When the PN junction diode works as insulator, if connected to AC or forward bias or reverse bias or none of these. Very simple answer. C. When you make a reverse bias of PN junction diode never conducts, means it is an insulator. So fifth answer is C. Okay, sixth one. Reverse biasing in PN junction diode is, when you make a reverse bias in PN junction, decrease the potential barrier, increase potential barrier, increase the number of charge carriers, and I'll go for next question, option also, increase the number of majority charge carriers. So correct option is B, increase the potential barrier. Okay, so I will show the diagram. This is a PN junction, PN junction, PN junction. When it is reverse bias, means this is reverse biasing. When you make a reverse bias, this is a potential barrier. This is what? Potential barrier. This potential barrier width increases, thereby resistance increases, conductivity decreases. Means the potential barrier width increases. So sixth option is D. Okay, next question. Next question, seventh one. The electrical resistance of depletion layer is large because it has no charge carriers, it has large number of charge carriers, it contains electrons as charge carriers, it has holes as charge carriers. Here I will draw the picture of the PN junction. This is P, this is N, this is a depletion layer. So we know that depletion layer means it has got fixed ions, negative ions and positive ions. So they have, due to this fixed ions, the charge carriers will not cross this junction. So correct option is, it has not got any charge carriers, it got only fixed ions. The fixed ions are present, fixed ions are present, so there are no charge carriers. So option is A. So next, eighth question. In the circuit given below, the value of current is, what is the value of current? See here, this is plus 4 volt circuit, this is plus 4 volt, this is plus 1 volt. Okay, resistance is 300 ohm. We know that I equal to VR. So we want the value of current. The value of current, V is what? 4, sorry, it is V equal to, sorry, we go for, here I go for Ohm's law. V equal to IR, V equal to IR. So I want I equal to V by R. Potential difference, here this is 4, this is 1. Difference is 4 minus 1. Potential difference. R is what? 300. So it is 3 by 300. 3 by 300 means 10 raised to minus 2 ampere. So correct option is B, 10 raised to minus 2 ampere. Okay, next question. What is the current? Ninth is over. See, where I go? So this is okay. Ninth question. What is the current in the circuit shown? Do it for the same time. Ninth one. See here, this is a negative connected to P. More negative is connected to P. If more negative is connected to P, it is reverse bias. If it is reverse bias, the current in the circuit is 0. The current in circuit is 0. Why current is 0 ampere? Because of more negative biasing. More negative connected to P. When more negative is connected to P, it becomes what? Reverse bias. In reverse bias, the current is 0. No, insulator current is 0. Okay, so option is A. So next one, 10th one. If a forward bias voltage in a semiconductor diode is doubled, the width of the depletion layer will increase. Okay, if the forward bias voltage is increased, doubled, what happens to the width of the layer? Width of the layer will increase or decrease? So that is a question. If you apply the forward voltage, automatically depletion layer will decrease. Depletion layer decrease. So C is not possible. It will unchanged, becomes doubled, not doubles. If voltage doubled, it will decrease, it will not get double. So which one is the correct option for A or B? If forward bias voltage is doubled, automatically depletion layer becomes half. So means option A is correct. Here on applying more and more voltage, depletion layer will become decrease because it is a forward, not reverse. Forward bias will decrease depletion layer, becomes half. Okay. So next question, 11th one. The PN junction diode is used as, the PN junction is used as rectifier. Simple answer. PN junction diodes are used as rectifiers. Okay. 12th question. When a PN junction diode is reverse bias, elect here. What happens to the options here? See here, which is the correct option? When a PN junction diode is reverse bias, option A, electrons and holes are attracted towards each other and move towards depletion region. Electrons and holes move away from the junction depletion region. Height of potential barrier increases. No change in current takes place. So correct option is electrons and holes move away from the junction. So correct option is B. If you look at the PN junction, so P, this is N. So the electrons and holes will move away from the junction when it is reverse biased. For reverse biasing, the P electrons and holes will move away from the junction. So B is correct option. So next one, 13th question. Two PN junctions can be connected in series by three different methods as shown in the figure. The potential difference is in the junctions is same. Then the correct connections will be. See here, for series connection, the two PN junctions are connected in series. Here look at the diagram. There are two PN junctions. They should be connected in series. So first diagram, PN, NP. So for series connection, we should have PN and PN or NP and NP. This is series combination picture, which is correct. So 2 is correct, PN and PN and NP and NPN. So 2 and 3 are correct option. So we have to go for options. Options are, see, look at the options. In circuit 1 and 2, no. In circuit 2 and 3, yes. 2 and 3 are correct PS series combinations. So 1 and 3 is not correct because 1 is not a correct one. It is not a series combination because it is. Okay, next question. So which is the correct option? Circuit 2 and 3. So next question, I'll move to next question. See here, 14th. A PN junction has a thickness of order of. So very simple, straightforward answer, 10 raised to minus 6 meter. So remember, my dear students, ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, PN junction diode has got how much thickness of the order of the junction? 10 raised to minus 6 meter. Okay. Next question. In the depletion region of unbiased PN junction diode, there are only electrons, only holes, both electrons and holes, only fixed ions. So in depletion region of an unbiased PN junction, it is not a biased. See here, unbiased PN junction has in depletion layer, in unbiased PN junctions, we are having fixed ions. As I told, PN junction depletion layer contains fixed ions. 15th is D. Okay, 16th question. On increasing the reverse bias to a large value in PN junction diode, the current. In reverse bias, if you increase the PN junction if you increase the reverse bias voltage to a large value in PN junction, what happens to current? Current will increase slowly, remains fixed, suddenly increases, decreases. So correct option is C. So I will show you the graphical in reverse bias mode. So this is current, this is biasing voltage, reverse biasing voltage. I will show the picture. So when you increase the voltage to a large value, the current also increases. The reverse current, it is a reverse current. Reverse current also suddenly increases. So option is C. So 18th question. Which of the following statements concerns the depletion layer of an unbiased PN junction is true or all true? There may be one statement true or two statements true. So see here, which of the following statements is correct for the depletion layer? Width of the zone is independent of density of dopants, impurities. So not correct, not correct. So width of the zone is dependent of density of dopants. Okay, correct, because width of the zone is dependent on density of dopants. If dopants are more, width of the zone will change automatically. So B is correct option. So electric field in the zone is produced by ionized dopant. So it is also correct, because in a PN junction, in the depletion layer, there are ionized fixed ions dopants. They will produce electric field. So here I will show it in the diagram again, once again. So if you take a PN junction, so there are positive fixed ions, there are negative fixed ions. This will produce electric field. This will produce electric field from positive to negative, means electric field is produced in the zone of depletion layer. So B and C are correct. And go for D also. Electric field in the zone is produced by electrons in conduction band and valency band. So not possible. So the correct options are B and C. Both are correct. D and E are wrong options. Okay. So next we move for 19th question. A semiconductor device is connected in series. A semiconductor device is connected in series with a battery and a resistance. A current is found to pass through the circuit. Semiconductor is connected in series with battery and resistance. Current pass through the circuit. If the polarity of the battery is reversed, the current drops almost to zero. If polarity is reversed, the current drops to zero. The device may be P-type, N-type, PN junction or intrinsic semiconductor. Okay, see here. A semiconductor device is connected to battery and resistance. First current flows. First current will pass through circuit. Next suddenly current drops to zero on reversing the polarities. If it is polarity is changing, automatically it should be PN junction. PN junction only the current will change, not for P type or N type. So option is C. Okay. So 20th question. The approximate ratio of resistance in forward and reverse bias of PN junction diode is. So approximate ratio of resistances. Resistance in forward RF is nearly 10 ohm, and it is forward bias. Resistance in reverse bias is almost or nearly 10 raised to 5. So when you take the ratio, it will be 10 by 10 raised to 5, means 1 by 10 raised to 4. 1 by 10 raised to 4 means D is correct option. Okay, now next we move for junction transistors. See here, my dear students, you have not gone through the transistors, but still for the Neet and JW preparations, we need transistor questions also. We need the knowledge of transistors and the questions of transistors. And I will try to, I'll maximum try to convenience you, although you are not learnt in the theory part of this transistors. You transistors ಬಗ್ಗೆ ಥಿಯರಿಯಲ್ಲಿ ಏನೂ ಕಲ್ತಿಲ್ಲ, ಆದರೂ ನಾನು ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಕೆಲವೊಂದು ಕ್ವಶನ್ಸನ್ನು ಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ, ಯಾಕಂದರೆ ನಿಮಗೆ JW ಮತ್ತು ನೀಟ್ಗೆ ಹೆಲ್ಪ್ ಆಗ್ಬೋದು. Okay, so start with the question. When NPN transistor is used as amplifier, NPN is moved. N acts as emitter, P acts as base, N acts as collector. So N ಒಳಗೆ ಏನಿರ್ತಾವೆ? Electrons move from in this direction. So electrons move from base to collector. So correct option. Correct option ಏನಾಗಬಹುದು? A ಆಗಬಹುದು. Check other options. Holes move from emitter to base. Holes move from emitter to base, not possible. Electrons move from collector to base, not possible. Holes move from base to emitter. Holes move from base to emitter. That is also not possible. So which is the correct option? A is the correct option. So electrons from N will move to P will move to N. Means electrons move from emitter to base to collector. So this is the first option is correct option. Okay. 2. The phase difference between input and output voltages of C circuit. Common emitter circuit. CE means what? Common emitter circuit. In common emitter circuit, input and see if it is input, it is what? Output. See here, input and output are opposite. When input and output, see here, for positive you get negative, for negative you get positive. This is input, this is output picture. For input you are getting negative output, for negative input you are getting positive output. Means input and output are opposite. If input and output are opposite means 180 degree. Opposite means 180 degree. So which is correct option? Third one is the correct, sorry, C is the correct option. Third one, C is correct option. Okay, move to the third question. Let us move to the third question. Let us third question. An oscillator is nothing but an amplifier with positive feedback, large gain, no feedback, negative feedback. Okay. Now I will draw the picture of oscillator. Oscillator ಒಳಗೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ this is the, I will show here. So in oscillator circuits, oscillators gives output and again the output is fed to the oscillator input. Output is converted to input again. Every time output comes and some of the output is fed back to the transistor, and it is fed means it is output is converted as again input. Output is connected as input. Output is fed to the input of the oscillator. Means positive feedback should be there. If positive feedback is there, then only this output is linked with what? The input. Oscillator ಒಳಗೆ ಏನಾಗುತ್ತೆ? ಔಟ್ಪುಟ್ ಕನ್ವರ್ಟ್ ಆಗಿ ಇನ್ಪುಟ್ ಆಗುತ್ತೆ, ಮತ್ತು ಇನ್ಪುಟ್ ಕನ್ವರ್ಟ್ ಆಗಿ ಔಟ್ಪುಟ್ ಆಗುತ್ತೆ. ಅಗೇನ್ ಔಟ್ಪುಟ್ ಈಸ್ ಕನ್ವರ್ಟೆಡ್ ಟು ಇನ್ಪುಟ್, ಇನ್ಪುಟ್ ಈಸ್ ಕನ್ವರ್ಟೆಡ್ ಟು ಔಟ್ಪುಟ್. So this is nothing but oscillating. So signal oscillates between input and output. ಅದಕ್ಕೆ ಏನಂತಾರೆ? ಅದಕ್ಕೆ ಆಸಿಲೇಟರ್. ಆಸಿಲೇಟರ್ ಅಂದರೆ ಕೊಟ್ಟ ಸಿಗ್ನಲ್ಲು ಇನ್ಪುಟ್ ಟು ಔಟ್ಪುಟ್ ನಡುವರೆ ಆಸಿಲೇಟ್ ಆಗುತ್ತೆ. ಅದು ಎಂಥ ಫೀಡ್ಬ್ಯಾಕ್ ಹೇಳ್ರಿ? ಪಾಸಿಟಿವ್ ಫೀಡ್ಬ್ಯಾಕ್. Okay, option 3, question number 3, option is A. Okay. Next one. Fourth question. The emitter-base junction of a transistor is dash biased, while collector-base junction is dash biased. None already I have told in theory part. I will draw the picture of the 3 parts. First one is emitter. Next middle is base, third one is collector. Emitter-base junction is always forward biased. Collector base junction is always reverse biased. So means option, see here, emitter base junction is forward biased, collector base junction is reverse biased. So option is forward and reverse. So option D is correct. Fourth one, option D is correct. Next, fifth one. In an NPN transistor, the collector current is 24 milliampere. 80% of electron reach collector. Its base current is okay. If you take emitter current, if it is 100% emitter current, out of 100% they given that collector current is how much? 80%, and remaining is what? Base will be 20%. 20%. If you add these two, it will become 100. Base plus collector current will give emitter current. So 80% is already given. 80% is nothing but 24 milliampere. Then what happens to 20% current? 20% is what? Base. 20% equal to question mark. So to solve cross multiplication, 80% ಅಂದ್ರೆ 24, 20% ಅಂದ್ರೆ ಎಷ್ಟು? 24 into 20 divided by 80. So 0 cancels, 2 1s are 2 4s are 4 1s are 4 6s are, and the United option 6 milliampere is the base current. 20% and the base current 6 milliampere. Okay, so next question. Okay, in a 6-1, a NPN transistor conducts. When NPN transistor conducts, both collector and emitter are positive with respect to base. Collector is positive and emitter is negative. C, collector is positive, emitter is at same potential with the base. D, collector and emitter both are negative with respect to base. So which one is the correct option? Now I will draw the diagram of NPN transistor. NPN, N, middle is P and N, NPN transistor. This should be forward biased. Forward bias means negative. This will be positive. Okay, this PN junction should be idu forward bias agirbeku. Adakke the negative should be connected to negative is connected to negative. Idu reverse bias negative should be connected to positive. Hagare idu for reverse bias negative connected to positive. Hagare see, this is collector, this is emitter, this is base, this is collector. Emitter is connected to negative, collector is connected to positive. So which is the correct option? Collector and emitter both are positive, not possible. B, collector is positive. Here collector is positive, emitter is negative with respect to base. Emitter is negative with respect to base. So which is correct option? B is correct option. 6-1 B. So next, in case of constants and alpha and beta of a transistor, so which one is correct? Alpha equal to beta, alpha beta less than 1, alpha greater than 1, alpha beta equal to 1, alpha into beta equal to 1, beta greater than 1, alpha less than 1. So now I am going to write what is alpha and what is beta. Alpha is what? Collector current divided by emitter current. Collector current divided by emitter current. What is beta? Beta is what? The ratio of collector current IC to the base current IB. So IC by IE means alpha, IC by IB means beta. We know that IE is more than IC, means alpha IE more than IC. Alpha will be less than 1. Alpha is less than 1 because IC less than IE. IE less than IE. IC less than IE. Beta is greater than 1. Why beta is greater than 1? Because collector current is greater than base current, means beta is greater than 1. Agar option ಏನಾಗುತ್ತೆ? Beta greater than 1, alpha less than 1. So option is D. Okay, so next move to the next question. I will move to okay, 8 question. Which of the following is true? Common base transistor is commonly used for maximum current gain. Common emitter is commonly used for maximum current gain. Common collector is commonly used for maximum current gain. Common emitter is least used transistor. See here, we have to remember this statement. Always CE mode is preferred as best mode. CE means common emitter mode is used. So option is B. Remember my students, which of the following statement is true? Means common emitter is commonly used for maximum current gain, means CE mode is used. So option is B. So next 9th question. If alpha equal to 0.98, current through I is 20 milliampere, then the value of beta. Alpha is given, I is 20 milliampere. You have to calculate you have to get beta. So what is the formula for beta? Beta is written as alpha by 1 minus alpha. Substitute and do the calculation. 0.98 divided by 1 minus 0.98. So do the calculation. 0.98 by 0.02. 0.98 by 0.092 means 98 by 2. 98 by 2 means 49. 49 means B option is correct. B option is correct. Okay. So next question. It will be 98 divided by 2 means 49. For a common base configuration of PNP transistor, IC by IE. IC by IE means beta. Beta is given. Then the maximum current gain in common emitter configuration is. The maximum current gain in common emitter configuration is. So beta is, see here, it is beta. It is not beta. So here it is not beta. It is not beta. It is IC by IE. IC by IE means alpha. Alpha is given. Alpha is 0.98. Now you have to get beta. So what is beta? Maximum current gain beta equal to. Beta is written as alpha divided by. Now I have to look at. See, this is the question. See here, alpha, 10th question. Alpha is IC by IE means 0.98. Maximum current gain in common term beta by 1 minus alpha. If you do the calculation, and 0.98 by 1 minus 0.98, again the option will become 24. 20, sorry, not 20, it will be what? 0.98 by 1 minus 0.98. So 24 is not given in the 49. It will become 49. 49 is not given in the option. So better to make one of the question as 49. So 49 is correct option, not printed in the option. So mistake is there. Option is not 49 given. So option only 49 ಎಲ್ಲೂ ಇಲ್ಲ, ಅದಕ್ಕೆ 49 ತಗೊಳ್ಳೋಣ. So correct option ಏನು ಹೇಳಿ? 49 is the correct option. 0.98 divided by 1 minus 0.98 means 49. D 5 ಇದೆ, 49 ಮಾಡ್ಕೊಂಬಿಡಿ, ಕರೆಕ್ಟ್ ಆಗಿಬಿಡುತ್ತೆ. ಓಕೆ. ಸೊ 11th question. Next we move forward to 11th question. 11th question ಅಲ್ಲಿ ನೋಡೋಣ. ಫಸ್ಟ್ ಕ್ವಶನ್ ಓದೋಣ. In a PNP transistor working as a common base amplifier, the current gain is 0.96 and the emitter current is 7.2 milliampere. The base current, okay, base current ಕೇಳಿದ್ದಾರೆ. ಸೊ ಅದಕ್ಕೆ ನೋಡೋಣ. ಕರೆಂಟ್ ಗೇನ್ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? ಅಲ್ಫಾ ಕರೆಂಟ್ ಗೇನ್ ಈಕ್ವಲ್ ಟು ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? ಕರೆಂಟ್ ಗೇನ್ ಫಾರ್ಮುಲಾ ಏನ್ರಿ? IC by IE ಎಷ್ಟಿದೆ? 0.96. ಮತ್ತು ಎಮಿಟರ್ ಕರೆಂಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ IE ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ ರೀ? ಎಮಿಟರ್ ಕರೆಂಟ್ ಇಟ್ ಈಸ್ ಗಿವನ್ ಆ್ಯಸ್ 7.2 milliampere. 7.2 milliampere. ನಾವು ನಮಗೇನು ಬೇಕಾಗಿದೆ? I need ಸರ್ ವಾಟ್ ಐ ನೀಡ್ ಈಸ್, ಕ್ವಶನ್ ಏನಿದೆ ನೋಡಿ, ಬೇಸ್ ಕರೆಂಟ್ ಕೇಳಿದ್ದಾರೆ. ಐ ಬಿ ಕೇಳಿದ್ದಾರೆ ಬೇಸ್ ಕರೆಂಟ್. ಓಕೆ, ಐ ಬಿ ಕೊಟ್ಟು. ಸೊ ಫಾರ್ ದಿಸ್ ಅಲ್ಫಾ ಕೊಟ್ಟಿದ್ದಾರೆ, IE ಕೊಟ್ಟಿದ್ದಾರೆ. ಈಗ IC ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ. IC ಈಕ್ವಲ್ ಟು ಏನಿದೆ ಹೇಳಿ? IC ಈಕ್ವಲ್ ಟು ಇಲ್ಲಿದೆ ನೋಡಿ, IC ಈಕ್ವಲ್ ಟು 0.96 ಇಂಟು IE. ಇದು ಮಾಡಿದಾಗ ಎಷ್ಟಾಗುತ್ತೆ ಹೇಳಿ? 0.96 ಇಂಟು 72. You will get 6.9. You will get 6.9 as IE. IB ಬೇಕು. IB equal to what? IB equal to IE minus IC. IE ಎಷ್ಟು ಬಂದಿದೆ? IE ಎಷ್ಟು ಬಂದಿದೆ? ಕೊಟ್ಟಿದ್ದಾರೆ 7.2 minus 0.69. ಸೊ 7.2 minus 0.69 ಅಂದರೆ ಎಷ್ಟಾಗುತ್ತೆ ಹೇಳ್ರಿ? ನಿಯರ್ಲಿ ಎಷ್ಟಾಗ್ಬೋದು? ಇಟ್ ವಿಲ್ ಬಿ ನಿಯರ್ಲಿ ಅರೌಂಡ್ 0.29. ಯಾಕಂದರೆ 7.2 minus 0.6 ಮಾಡಿದ್ರೆ ನಿಯರ್ಲಿ ಅರೌಂಡ್ 0.29 ಮಿಲಿ ಆಂಪಿಯರ್ ಬರ್ಬೋದು. ಹೇಗೆ ಬಂತ ಹೇಳ್ರಿ? ಹೌ ಇಟ್ ಕೇಮ್? ಆಲ್ಫಾ ಈಕ್ವಲ್ ಟು ಐ ಸಿ ಬೈ ಐ 0.96 ಗಿವನ್. I 7.2 milli ampere, that is also given. So 7.2, okay, IC equal to 0.96 into I, 0.96 into 7.2, so multiply ಮಾಡಿದ್ರೆ 6.9, subtract ಮಾಡಿದ್ರೆ 0.29 ಬರ್ಬೋದು nearly. So 0.29 is the correct option. Okay, next 12th question. L1, L2, L3 are the lengths of emitter, base and collector of a transistor. Then, see here, now I will draw the picture of emitter, base and collector. This is, see here, emitter. Sorry, once again I have to get. See here, this is emitter, this is base. This is collector. See here, emitter is medium, base is least, collector is highest. So L3 is highest. L length of base, L2 is least, L1 is medium. L1 is medium, L2 is least, L3 is highest. Agar L3 greater than L1, L1 greater than L2. अगर ಏನಾಗುತ್ತೆ ಆಪ್ಷನ್ L3 greater than L1, L1 greater than L2. L3 ಅಂದರೆ collector greater than emitter L1, emitter greater than base L2. So option D is correct. Okay. So now I will move to what? Digital electronics. So I will solve the questions on digital electronics. Okay. So first question of digital electronics. Given below are symbols of some logic gates. So first one, it is NAND gate, it is XOR gate, third one NOR gate, NOT gate. ನಮಗೇನು ಬೇಕಾಗಿದೆ? NOR and XOR and NOR gate. XOR ಯಾವುದಾಗುತ್ತೆ ಹೇಳಿ? 2. NOR ಯಾವುದಾಗುತ್ತೆ ಹೇಳ್ರಿ? 4. ಹಾಗಾದ್ರೆ 2 and 4. Sorry, NOR either. Sorry, not NOR. 2 and 3 is correct option. XOR is 2, NOR is 3. Which one is correct option? B, 2 and 3. XOR and 2, NOR and 3. 2 and 3. So first option B is correct. Next, given below are 4 logic gate symbol. Those are for OR, NOR, NAND respectively. So for OR gate, 1 is correct. This is OR. So for NOR gate, 3, NOR symbol. Then NAND, 4. So which one is the correct option? 1, 3, 4. 1, 3, 4 is C. OR, NOR, NAND. 1, 3, 4. C is the correct option. So third one, following truth table corresponds to the logic gates. A and B are inputs, X is output. A and B are inputs, X is output. 0, 0 gives 0. 0, 1 gives 1. 1, 0 gives 1. 1, 1 gives 1. Means 0 plus symbol is used. 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, 1. Which is a plus symbol? Plus symbol is given for OR gate. OR gate means B is correct option. Okay. So next we go for the combination of NAND gates shown are equivalent to the combinations of NAND gate. NAND gates are given here. Which one is equivalent to correct options? So first one, it's here. Here it is A bar. This is B bar. When A bar and B bar are mixed, C equal to ಇದು A ನಾಟ್ ಆಗಿದೆ, A ಬಾರ್, ಇದು B ಬಾರ್ ಆಗಿದೆ. ಏನಾಗುತ್ತೆ ಹೇಳಿ? ಇಟ್ ಈಸ್ A ಬಾರ್ ಡಾಟ್ ಬಿ ಬಾರ್ ಹೋಲ್ ಬಾರ್, ಯಾಕೆ ನಾಟ್ ನ್ಯಾಂಡ್ ಗೇಟ್ ಇದೆ, ನ್ಯಾಂಡ್ ಅಂದರೆ ಮತ್ತೆ ಔಟ್ಪುಟ್ ಬಾರ್ ಆಗಿಬಿಡುತ್ತೆ. ಎ ಬಾರ್, ಸೊ ಇಟ್ ಈಸ್ ಡಾಟ್ ಬಿ ಬಾರ್. ಹಾಗಾದ್ರೆ ಟೋಟಲ್ ಏನಾಗುತ್ತೆ ಹೇಳಿ, ಎ ಬಾರ್ ಡಾಟ್ ಬಿ ಬಾರ್ ಅಂದರೆ ನೀವು ಸಪ್ರೇಟ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಸಪ್ರೇಟ್ ಮಾಡಿದಾಗ ಎ ಬಾರ್ ಆಫ್ ಬಾರ್ ಬಿ ಬಾರ್ ಆಫ್ ಬಾರ್ ಬೂಲಿಯನ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಪ್ರಕಾರ, ಅಲ್ಜಿಬ್ರಿಕ್ ಬೂಲಿಯನ್ ಇಕ್ವೇಷನ್ಸ್ ಪ್ರಕಾರ ಎ ಬಾರ್ ಡಾಟ್ ಬಿ ಬಾರ್ ಹೋಲ್ ಬಾರ್ ಇದ್ದರೆ ಎ ಡಬಲ್ ಬಾರ್ ಬಿ ಡಬಲ್ ಬಾರ್, ಎ ಬಾರ್ ಡಬಲ್ ಬಾರ್ ಅಂದರೆ ಎ, ಬಿ ಡಬಲ್ ಬಾರ್ ಅಂದರೆ ಬಿ. ಹಾಗಾದ್ರೆ ಇದೇನಾಯ್ತು ಹೇಳಿ, ಸಿ ಈಕ್ವಲ್ ಟು ಎ ಪ್ಲಸ್ ಬಿ ಅಂದರೆ ಆರ್ ಗೇಟ್. ಹಾಗಾದ್ರೆ ಫಸ್ಟ್ ಒನ್ ಈಸ್ ಆರ್ ಗೇಟ್. ಸೆಕೆಂಡ್ ಒನ್ ಸಿ ಈಕ್ವಲ್ ಟು, ಇಲ್ಲಿ ನೋಡಿ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ನೋಡೋಣ. ಸೆಕೆಂಡ್ ಒನ್ನಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಇಲ್ಲಿ ಎ ಬಿ ಎರಡು ಔಟ್ಪುಟ್ ಹೊರಗೆ ಬಂದರೆ ಎ ಡಾಟ್ ಎ ಡಾಟ್ ಬಿ ಬಾರ್, ಎ ಡಾಟ್ ಬಿ ಬಾರ್. ಸಿ ಕೊಟ್ಟು ಹೊರ ಬಂದಾಗ ಏನಾಗುತ್ತೆ ಹೇಳಿ, ಸಿ ಕೊಟ್ಟು ಹೊರ ಬಂದಾಗೆ ಏನಾಗುತ್ತೆ ನೋಡೋಣ. ಇದೇನಾಗುತ್ತೆ, ಸಿ ಈಕ್ವಲ್ ಟು ಫಸ್ಟು ಎ ಡಾಟ್ ಬಿ ಬಿ ಬಾರ್ ಒಂದನೇದ್ದು, ಎರಡನೇದ್ದು ಡಾಟ್ ಎ ಬಿ ಬಾರ್ ಹೋಲ್ ಬಾರ್. ಎರಡೂ ಸಾಲ್ವ್ ಮಾಡಿದಾಗ ಅಲ್ಜಿಬ್ರಾಯಿಕ್ ಇಕ್ವೇಷನ್ಸ್ ಪ್ರಕಾರ ಸಾಲ್ವ್ ಮಾಡಿದಾಗ ಇದೇನಾಗುತ್ತೆ ಹೇಳಿ, ಎ ಬಿ ಬಾರ್ ಹೋಲ್ ರೇಸ್ ಟು ಬಾರ್ ಪ್ಲಸ್ ಎ ಬಿ ಬಾರ್ ಹೋಲ್ ರೇಸ್ ಟು ಬಾರ್. ಹಾಗಾದ್ರೆ ಏನಾಯ್ತು ಹೇಳಿ, ಎ ಬಿ ಪ್ಲಸ್ ಎ ಬಿ, ಎ ಬಿ ಪ್ಲಸ್ ಎ ಬಿ, ಎ ಬಿ ಪ್ಲಸ್ ಎ ಬಿ ಅಂದರೆ ಏನಾಗುತ್ತೆ ಹೇಳಿ, ಎ ಬಿ ಪ್ಲಸ್ ಎ ಬಿ ಮೀನ್ಸ್ ಎ ಬಿ ಪ್ಲಸ್ ಎ ಬಿ ಮೀನ್ಸ್ ಎ ಡಾಟ್ ಬಿ, ಎ ಡಾಟ್ ಬಿ ಅಂದರೆ ಇದು ಆ್ಯಂಡ್ ಗೇಟ್. ಹಾಗಾದ್ರೆ ಏನಾಗುತ್ತೆ ಹೇಳಿ, ಆ್ಯಂಡ್ ಗೇಟ್. ಸೊ ಆ್ಯಂಡ್ ಗೇಟ್ ಅಂದರೆ ಯಾವ್ದು ಹೇಳಿ, ಒಂದನೇದು ಆರ್ ಗೇಟ್, ಎರಡನೇದು ಆ್ಯಂಡ್ ಗೇಟ್. ಹಾಗಾದ್ರೆ ಆಪ್ಷನ್ ಯಾವುದಾಗ್ಬೋದು, ಆ್ಯಂಡ್ ಆರ್ ಆ್ಯಂಡ್ ಗೇಟ್ ಅಂದರೆ ಎ ಈಸ್ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್. ಓಕೆ, ಎ ಈಸ್ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಹೋಗೋಣ. ಓಕೆ, ಎ ಟ್ರುತ್ ಟೇಬಲ್ ಈಸ್ ಗಿವನ್ ಬಿಲೋ, ವಿಚ್ ಆಫ್ ದ ಫಾಲೋಯಿಂಗ್ ಹ್ಯಾಸ್ ದಿಸ್ ಟೈಪ್ ಆಫ್ ಟ್ರುತ್ ಟೇಬಲ್. ಈ ಟೈಪ್ ಟ್ರುತ್ ಟೇಬಲ್ ಯಾವುದು ಇರ್ಬೋದು, 0 0 1 1 0 1 0 0 1 1 1 1 1 0. ಹಾಗಾದ್ರೆ ಯಾವುದಾಗ್ಬೋದು ಹೇಳಿ, 0 ಪ್ಲಸ್ 0 ಗಿವ್ಸ್ 0. ಹಾಗಾಗಿ ಸಿಂಬಲ್ ಆಫ್ ಏನಾಗ್ಬೋದು ಹೇಳಿ, y ಈಕ್ವಲ್ ಟು ಎ ಪ್ಲಸ್ ಬಿ ಬಾರ್ ಆಗ್ಬೋದು ನೋಡಿ, ಎ ಪ್ಲಸ್ ಬಿ ಬಾರ್. 0 ಪ್ಲಸ್ 0 ಬಾರ್, 0 ಪ್ಲಸ್ 0 0 0 ಬಾರ್ 1. ಸೊ ಹಾಗಾದ್ರೆ ಎ ಪ್ಲಸ್ ಬಿ ಹೋಲ್ ಬಾರ್ ಅಂತ ಯಾವ್ದು ಹೇಳಿ, ನಾರ್ ಗೇಟ್. ಎ ಪ್ಲಸ್ ಬಿ ಬಾರ್ ಅಂತ ಯಾವುದು, ನಾರ್ ಗೇಟ್. ಸೊ ಫಿಫ್ತ್ ಒನ್ ಈಸ್ ಬಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ 6-1. The truth table given in the figure is for which gate? So 0 0 gives 1, 0 1 gives 1, 0 1 0 0 1 1 1. See if 0 ಇನ್ಪುಟ್ ಎರಡು 0 0 1 ಅಥವಾ 1 1 1 ಇದ್ದಾಗ ಯಾವ ಗೇಟ್ ಅಂತೇಳಿ, ಎಕ್ಸ್ ನಾರ್ ಗೇಟ್. ಎಕ್ಸ್ ನಾರ್ ಗೇಟ್ ಗೊತ್ತಿರ್ಬೋದು, ನಾ ಹೇಳಿದೆ y ಈಕ್ವಲ್ ಟು ಫಸ್ಟ್ ಥಿಯರಿ ಹೇಳಿದಾಗ ಹೇಳಿದ್ದು ನೋಡಿ, ಎ ಪ್ಲಸ್ ಆಫ್ ಬಿ ಇದು ಎಕ್ಸ್ ಆರ್, ಇದಕ್ಕೆ ಮೇಲೆ ಬಾರ್ ಹಾಕಿದರೆ ಎಕ್ಸ್ ನಾರ್ ಗೇಟ್ ಏನು ಹೇಳ್ರಿ, ಎ ಪ್ಲಸ್ ಆಫ್ ಬಿ ಬಾರ್. ಅದರ ಆಪ್ಷನ್ ಯಾವ್ದು ಹೇಳ್ರಿ, ಎಕ್ಸ್ ನಾರ್. ಸಿಕ್ಸ್ತ್ ಒನ್ ಈಸ್ ಸಿ. ಇದ್ರ ಫಾರ್ಮುಲಾ ಬರ್ತೀನಿ ನೋಡಿ ನಾನು. ಇದ್ರ ಫಾರ್ಮುಲಾ ಏನಾಗುತ್ತೆ ಅಂತಂದರೆ, ಎಕ್ಸ್ ನಾರ್ದು ಎ ಬಿ ಪ್ಲಸ್ ಎ ಬಾರ್ ಬಿ ಬಾರ್, ಎ ಬಾರ್ ಬಿ ಬಾರ್. This is a formula for X NOR gate. Next question. For a given combination of gates, if the logic gates of inputs A, B, C are as follows. See A equal to B equal to C. ಒಂದೇ ನೋಡಿ. First, ಇಲ್ಲಿ 0 0 0 plus 0 it is 0. ಇಲ್ಲೂ 0 0 ಇದು 0 ಬರುತ್ತೆ, ಇಲ್ಲೂ 0 0 ಡಾಟ್ 0 ಬಾರ್ ಆಗುತ್ತೆ. ಇದು ನ್ಯಾಂಡ್ ಗೇಟ್. 0.0 ಡಾಟ್ ಗೇಟ್ ಆಗುತ್ತೆ, ಇದು 1. ಸೊ ಹಾಗಾದರೆ ಫಸ್ಟ್ ಕಾಂಬಿನೇಷನ್ ಆನ್ಸರ್ ಏನು, 1. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ಗೆ ಎ ಬಿ ಸಿ ಆ್ಯಸ್ ಎ ಈಕ್ವಲ್ ಟು ಬಿ ಈಕ್ವಲ್ ಟು 1, ಎ ಈಕ್ವಲ್ ಟು 1, ಬಿ ಈಕ್ವಲ್ ಟು 1. ಹಾಗಾದ್ರೆ ಏನು ಸಿಗುತ್ತೆ? ಎ ಈಕ್ವಲ್ ಟು ಬಿ ಈಕ್ವಲ್ ಟು 1 ಆದರೆ ಇದು 1 + 1 1. ಹಾಗಾದ್ರೆ ಇಲ್ಲೇನು ಬಂತು? 1 ಬಂತು. ಇದು 0 ಬರುತ್ತೆ. ಹಾಗಾದ್ರೆ ಏನಾಯ್ತು ಆನ್ಸರು? 1.0 ಬಾರ್. 1.0 ಏನು ಹೇಳ್ರಿ? 0. 0 ಬಾರ್. 0 ಬಾರ್ ಅಂದೇನು? 1. ಹಾಗಾದ್ರೆ 1 1 ಈಸ್ ಕರೆಕ್ಟ್. 7th one is D is correct. Okay. So next question, I will move to next question. 8th, the Boolean algebra is essentially based on the Boolean algebra is essentially based on logic gates. So option B is correct. The logic behind NOR gate is that it gives logic gate behind the logic behind NOR gate. It gives here NOR gate ಹೇಳ್ರಿ y equal to a plus b bar. a plus b bar. High output when both inputs are low. ಟ್ರುತ್ ಟೇಬಲ್ ಹಾಕೋಣ. ಟ್ರುತ್ ಟೇಬಲ್ ಇತ್ತಲ್ಲ ಆಗಲಿ ಜಸ್ಟ್ ಬ್ಯಾಕ್ ಯು ಗೋ. 9th one NOR gate ಏನಾಗುತ್ತೆ? a plus b bar when okay 9th one a plus b bar. So when high output when both inputs are low. When both inputs are low it gives high output. ನೋಡಿ 0 plus 0 0 plus 0 0 0 ಬಾರ್ 1. ಹಾಗಾದರೆ 9th one ಏನಾಗುತ್ತೆ? 1 ಆಗ್ತದೆ. ಲೋ ಇನ್ಪುಟ್ ವೆನ್ ಬೋತ್ ಇನ್ಪುಟ್ಸ್ ಆರ್ ಲೋ, ನಾಟ್ ಪಾಸಿಬಲ್. ಹೈ ಇನ್ಪುಟ್ ವೆನ್ ಬೋತ್ ಇನ್ಪುಟ್ಸ್ ಆರ್ ಹೈ, ನಾಟ್ ಪಾಸಿಬಲ್. ಸೊ ಆಪ್ಷನ್ ಏನು ಹೇಳಿ? ವೆನ್ ಇನ್ಪುಟ್ಸ್ ಆರ್ ಬೋತ್ ಇನ್ಪುಟ್ಸ್ ಆರ್ ಲೋ 0 plus 0 0 plus 0 ಏನಾಗುತ್ತೆ? 0 plus 0 0 0 ಬಾರ್ ಅಂದರೆ 1. ಹಾಗಾದರೆ ಔಟ್ಪುಟ್ ಈಸ್ ಹೈ ವೆನ್ ಬೋತ್ ಇನ್ಪುಟ್ಸ್ ಆರ್ ಲೋ. ಸೊ 9th one is A. So next question, a logic gate is an electronic circuit which makes logic decisions. Simple. 10th option is A. So next question, a gate has the following truth table: 1 1 1 1 0 0 0 1 1 0 1 0 1 0 0 0. So which is the truth table for this? 11th one is NAND gate. So here R equal to P dot Q 1.1 1 1.0 0 0.1 0 0.0 0 means AND gate. AND gate is the correct option. So next question, 12th one. How many NAND gates are used to form AND gate? How many AND gates are used to form one AND gate? So correct option is 2. 2 AND gates will make one AND gate. See here 2 NAND gates. I will draw the picture of. See here, this is one NAND gate, A, B. This is again, this is NAND gate. So 1 and 2 NAND gates will make one AND gate, means B. Which of the following gates will have an output 1? So it is AND gate. 1.0 it will be 0. This is 0 plus 1 0 plus 1 bar, because it is OR gate. 0 plus 1 bar is 1 bar. 1 bar means 0. It is not also correct. 0.1 bar. 0.1 bar it will give us 1. So our C is correct option. 13th is C option. ಇದನ್ನು ಚೆಕ್ ಮಾಡೋಣ. ಇದು ಎಕ್ಸ್ಕ್ಲೂಸಿವ್ OR ಗೇಟ್. ಇದು ನಾಟ್ ಪಾಸಿಬಲ್. ಎಕ್ಸ್ಕ್ಲೂಸಿವ್ OR ಗೇಟ್ ಇದು ಪಾಸಿಬಲ್ ಇಲ್ಲ. ಸೊ ವಿಚ್ ಇಸ್ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್? ಡಿ. ಯಾಕಂದರೆ ಎಕ್ಸ್ಕ್ಲೂಸಿವ್ OR ಗೇಟಲ್ಲಿ 2 0 0 ಇರಬೇಕು ಅಥವಾ 2 1 1 ಇರಬೇಕು, ಆವಾಗ ಮಾತ್ರ 1 ಆಗುತ್ತೆ. ಸೊ ಆಪ್ಷನ್ C is correct, not D. It is exclusive OR gate, so it is not correct. So next question, which represents AND gate? Which represents AND gate? AND gate ಯಾವ್ದಾಗುತ್ತೆ ಹೇಳಿ ನೋಡು. NAND, sorry, AND ಅಲ್ಲ, NAND. This is AND followed by NOT. AND followed by NAND gives NAND gate. 14th option is E. The given truth table is A is 0, X is output is 1, A is 1, output is 0, means NOT gate. Simple. 16. What will be the input of A and B for the Boolean expression 1A plus B bar dot A plus dot B bar equal to 1? ಏನಾಗ್ಬೋದು ನೋಡಿ, ಇದು 1 ಬರಬೇಕು, ಇದು 1 ಬರಬೇಕು ನೋಡಿ, ಚೆಕ್ ಮಾಡಿ 0 0 0 0 ಬರಲಿರುತ್ತೆ, 0 ಪ್ಲಸ್ 0 ಬಾರ್ 0 ಪ್ಲಸ್ 0 0 0 ಬಾರ್ 1 0 ಡಾಟ್ 0 0 ಡಾಟ್ 0 ಮೀನ್ಸ್ 0 0 ಬಾರ್ 1 ಅಂದರೆ 1 1 1 ಡಾಟ್ 1 1. ಹಾಗಾದ್ರೆ ಆಪ್ಷನ್ ಏನಾಗುತ್ತೆ ಹೇಳಿ, 16th ಒನ್ ಎ ಈಸ್ ಕರೆಕ್ಟ್. ಇವೆಲ್ಲ ಚೆಕ್ ಮಾಡಿದರೆ ರಾಂಗ್ ಬರುತ್ತೆ, ಚೆಕ್ ಮಾಡಿ ನೋಡಿ ರಾಂಗ್ ಬರುತ್ತೆ, ಆಪ್ಷನ್ ಎ ಈಸ್ ಕರೆಕ್ಟ್. So 0 1 will not get 0 1 0 1 0 will not get 1 1 1 will not also get 1. So option is A is correct. 16th is A. 17th, if A and B are two inputs in AND gate, then AND gate has an output 1 when values of A and B are, when A and B are both are 1, when A and B both are 1, 1 and 1 gives 1. ಹಾಗಾದರೆ ಆ್ಯಂಡ್ ಗೇಟ್ ಏನಾಗುತ್ತೆ ಹೇಳ್ರಿ, ಎ ಬಿ ಆ್ಯಂಡ್ ಔಟ್ಪುಟ್ ವೈ. ಇಫ್ ಎ ಆ್ಯಂಡ್ ಬಿ ಆರ್ 1, ಓನ್ಲಿ ಔಟ್ಪುಟ್ ಈಸ್ 1 ಬಿಕಾಸ್ ವೈ ಈಕ್ವಲ್ ಟು ಎ ಡಾಟ್ ಬಿ. ಹಾಗಾದ್ರೆ ಔಟ್ಪುಟ್ ಎರಡು 1 ಇರಬೇಕು, ಇನ್ಪುಟ್ ಎರಡು 1 ಇರಬೇಕು, ಔಟ್ಪುಟ್ 1 ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಒನ್ ಈಸ್ 18th, ಬೂಲಿಯನ್ ಇಕ್ವೇಷನ್ ಫಾರ್ ನಾರ್ ಗೇಟ್. ನಾರ್ ಗೇಟ್ ಏನು ಹೇಳಿ, ಎ ಪ್ಲಸ್ ಬಿ ಬಾರ್ ಸಿ. ಸಿ ಈಸ್ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್. 18th is sorry, B is correct. 18th B is correct, not C, B. Next question, we move for next question. So 19th question. Okay, this symbol represents, so here y equal to, it is, this symbol represents which question, 19th. See here, A B bar whole raised to bar. Both are same, input and outputs are same. Input and outputs are same means, here is first A is also input, B is also input. Now it will be like this, A bar or B bar, A bar or B bar. So means it is not gate, it is not gate. So 19th option is not gate, A. Next 20th, which logic gate is represented by following diagrams? This logic gate is for AND gate. 20th option is A. Next 29. So some questions are missing. I will go for 29 question. Sum of the two binary numbers is, so this is a binary system number. Now I will go for binary addition of numbers. Okay, so binary addition. Say 1, I will write first one 1 0, 2 zeros, 3 zeros, 4 zeros, again 1, again 1 0, 2. How to convert this into? It is converted into how many? Look at the numbers. How many numbers are there? 1 2 3 4 5 6 7. There are 7 numbers here. In the first one, say 1 0 is missing actually. Okay, it is 1 0 is, you delete 1 0 here in the question itself, you delete 1 0, you make it as 3 zeros, and totally how many terms are there? 1 2 3 4 5 6 numbers. You have to start with 2 into 10 raised to 5, 1a number. First one 1 into 2 into 10 raised to 5. Next, 4th is absent, 5th is absent, 5th, 4th, 3rd, 2nd, and first one 2 into 10 raised 2 into 10 raised 2 raised to 1 into 10. This is 2 raised to 5 into 1, not 10 raised to 5, 2 raised to 5 into 1. ಇದು 2^5, ಇದು 2^4, 2^3, 2^2, 2^1, 2^0, 2^5 and 2^1 are present. ಹಾಗಾದರೆ ದಿಸ್ ಇಸ್ ಏನಾಗುತ್ತೆ ಇದು ಟೋಟಲ್ 2^5 means 32, 32 means plus 2, 34, 34. Now we will get 34 to the base 10. 2 is converted into 10 decimal. Next ಅದೇ ರೀತಿ ಸಿಗ್ನಲ್ 1 0 ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಇಲ್ಲಿ 1 0 ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ಕೊಂಡು ಹೇಳೋದು. ನೆಕ್ಸ್ಟ್ ಒನ್ ಇದೆ 1 1 0 1 1 ಟು ದ ಬೇಸ್ 2. ಇದು ಹೆಂಗೆ ಮಾಡಬೇಕು ಇಲ್ಲಿ ನೋಡಿ, ಇದು 2 ನೋಡಿ ಎಷ್ಟು ನಂಬರ್ಸ್ ಇದೆ ನೋಡಿ, 1 2 3 4 5 5 5 ಇಂದ 2^4 ಫಸ್ಟು, ನೆಕ್ಸ್ಟು 2 ಎರಡನೇದು ಇದೆ 1 ಇದೆ, ಹಾಗಾದ್ರೆ 2^3 ಇದ್ದಂಗೆ, ಪ್ಲಸ್ ಮೂರನೇದಿಲ್ಲ ಅಂದರೆ 2^2 ಇಲ್ಲ, ಫಸ್ಟ್ ನಾಲ್ಕನೇದಿದೆ 2^1 ಇದೆ, ನೆಕ್ಸ್ಟ್ ಲಾಸ್ಟ್ 2^0. ಹಾಗಾದ್ರೆ ಏನಾಗುತ್ತೆ ಹೇಳಿ 2^4 3 2^3 2^1 2^0. ಹಾಗಾದ್ರೆ 2^4 ಎಷ್ಟಾಗುತ್ತೆ, ಇವೆಲ್ಲ ಎಡಿಷನ್ ಮಾಡಿದಾಗ if you do the addition of all these you will get 16 plus 8 plus 2 plus 1, ಇದು 2^1 ಆಗ ಟೋಟಲ್ ಏನಾಗುತ್ತೆ ಇದು 16 plus 10 26 27 ಆಗುತ್ತೆ, 27 ಇಷ್ಟು 27 10 ಆಗುತ್ತೆ. ಇವೆರಡು ಕೂಡಿಸಿದಾಗ ಏನಾಗುತ್ತೆ 34 plus 27, 34 plus 27 ಎಷ್ಟಾಗುತ್ತೆ 61 ಬಂತು. ನಮ್ಮ ಆಪ್ಷನ್ 61 ಇಲ್ಲಲ್ಲ, ಅದನ್ನು ಮತ್ತೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. 61ಅನ್ನು ಮತ್ತೆ ಬೈನರಿ ಸಿಸ್ಟಮ್ ಕನ್ವರ್ಟ್ ಮಾಡೋಣ. ಬೈನರಿ ಅಂದರೆ ನೋಡಿ 2 61 ರಿಮೈಂಡರ್ ಹೇಳ್ಕೊತವನ ರಿಮೈಂಡರ್ 2 30s 1 ರಿಮೈಂಡರ್. ನೆಕ್ಸ್ಟ್ 2 15s 0 ರಿಮೈಂಡರ್ ಬರಲ್ಲ. ನೆಕ್ಸ್ಟ್ 2 7s 14 1 ರಿಮೈಂಡರ್, ಮತ್ತು 2 3s 6 ಮತ್ತು 1 ರಿಮೈಂಡರ್, ಮತ್ತು 2 1s 2 ಮತ್ತು 1 ರಿಮೈಂಡರ್. ಲಾಸ್ಟಿಗೆ ಏನು ಉಳಿತು 1 ಉಳಿತು. ಹಾಗಾದ್ರೆ ಏನಂತ ಹೇಳಿ ಆನ್ಸರ್, ಹಾಗಾದ್ರೆ ಒಂದು ಏನು ಉಳಿತು ಆನ್ಸರ್ ಹೇಳಿ 1 1 0 0, ಇನ್ನೊಂದು ರಿಮೈಂಡರ್ 1 1 0 1 1 1. ಹಾಗಾದರೆ 1 0 1 1 1 ಅನ್ನೋದು ಯಾವುದಾಗುತ್ತೆ, ಸಿ ಈಸ್ ದ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್. ಸಿ ಈಸ್ ದ ಯಾವುದಾಗುತ್ತೆ 1 0 1 1 1 1. ಹಾಗಾದ್ರೆ ಆಪ್ಷನ್ ಏನಾಗುತ್ತೆ ಹೇಳಿ 1 0 1 1 ಅಂದು ಯಾವುದಾಗುತ್ತೆ ಆಪ್ಷನ್, ಸಿ ಈಸ್ ದ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್. ಸಿ ಕರೆಕ್ಟ್ ಆಗುತ್ತೆ. ಓಕೆ, ಇಲ್ಲ ರಿವರ್ಸಲ್ಲಿ ರೀಡ್ ಮಾಡೋಕ್ಕೂ ರಿಕ್ವೈರ್ಡ್ ಸಮ್ ಈಸ್ 111. ರಿವರ್ಸಲ್ಲಿ ರೀಡ್ ಮಾಡೋಕ್ಕೂ ನಾವು ಇಲ್ಲಿ ನೋಡಿ 1 1 1 1 0 1. ಹಾಗಾದ್ರೆ ಏನಾಗುತ್ತೆ ಇದು ರಿವರ್ಸಲ್ಲಿ ರೀಡ್ ಮಾಡಿದರೆ 1 1 1 0 1. ಹಾಗಾದ್ರೆ ಆಪ್ಷನ್ ಏನಾಗುತ್ತೆ ಹೇಳಿ ಎ ಇಸ್ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್. 1 1 1 1 0 1. ಹಾಗಾದ್ರೆ ಆಪ್ಷನ್ ಏನಾಗುತ್ತೆ ಹೇಳಿ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್ ಈಸ್ ಎ. ನೆಕ್ಸ್ಟ್ 30th ಕ್ವಶನ್. The truth table given below is for which gate? Truth table given for which gate is, see here 0 0 1 0 1 1 1 0 1 1 1 0 means 0 plus 0 bar. 0 plus 0 bar means what? 0.0 0.0 0 0 bar 1 0.1 0 0 bar 1. ಹಾಗಾದ್ರೆ ಏನಾಗುತ್ತೆ ಹೇಳಿ NAND gate. Surely NAND gate is 30th option. The logic gate is NAND gate. Okay, so with this let's stop the class. Thank you.